Okay. Can we start? Yes. Welcome. Welcome here in Ostend at the Flanders Marine Institute, VLIZ, for this, what will become undoubtedly a very inspiring workshop on citizen science and data management. My name is Jan Sees. I'm Head of Science Communication and spokesperson of the Flanders Marine Institute, VLIZ. And VLIZ will also take care for the logistics here of this workshop. So if you have any issue, don't hesitate to ask. I have to apologize, Nancy. Some of you, of course, most of you know Nancy. She fell sick yesterday. She was very sorry not to be with us, but we will do whatever we can to replace her. Yes, at VLIZ we are believers in citizen science. That's quite clear, not only because it's a very strong tool to create engagement and awareness and ocean literacy, but also because we need the data that citizens can collect and are already collecting. So that's quite crucial. That means we've been investing in citizen science for quite a long time. And we have several projects that we are coordinating. Two of them, I will come back to that later on this afternoon. SeaWatch-B and the big annual seashell survey. But we also work on litter in rivers and coastlines with the plastic pirates. We've been working globally with the Collect project on litter. We work with recreational fishermen on citizen science. We look at coastal erosion with CoastSnap. And we've been publishing in State of the Art of Citizen Science with Carlos Garcia Soto of CSIC, and also part of this CS-MACH consortium. And we've been working with them together also and with Quanta Labs to produce our Minca.be, again, which I will look into a bit deeper later on. And finally, we made an inventory. I think VLIZ made the first inventory in Europe of riverine, coastal and marine citizen science initiatives, more than 1,000 initiatives. And that helped us also to become part of CS-MACH1. And I will not speak more. And I love to give the floor now to Emily. She's the work package leader number 2 from the project, so you'll have the floor.
Thank you. So, good afternoon, everyone. I wish you a very warm welcome to the Marine Citizen Science Data Network workshop. I'm glad to see so many of you in the room, and I hope you're also very numerous online. My name is Emilie Brevière. I'm part of the Swedish Meteorological and Hydrological Institute, SMHI, in Sweden, and I'm partner of the CS-MACH1 project. I co-organized this workshop with my fellow project partners, which are very numerous also in the room and also online. I'm not forgetting them. We have a very packed schedule. So one of the first key I should not forget to remind you is be on time. And don't overspeak during your speech, otherwise you'll be stopped by a very nice clapping. We will clap. That will mean thank you very much, but we need to move to the next person. So that's how we're gonna help you to control the time. We will also try to answer questions in the room, but also online. You will have the possibility to enter your questions in the chat, and later on during the afternoon on the Menti matter, we'll give you instruction. We will not have the possibility, of course, to answer all your questions put on the chat or on the Menti. We hope to be able to reply to you after the workshop, but this means you have to leave us an email address or a way to contact you. We'll use this only for the purpose of the workshop and to reply to you. But if we don't have your information, we cannot reply to your question. We'll also not only take questions, we'll take also comments, suggestions and feedback. This workshop is really about co-designing the data network of marine citizen science. So it's really important that you share with us your needs, what you think about what we propose, what you wish we would propose, etc. Sorry, I took some notes, but can't see properly. Yeah, so I think I mentioned the most essential points. There's many of us that will do our best to make this workshop fruitful and helpful. But as always, when you have a nice symphony orchestra, you need a conductor, and I'll be very pleased to be that person. So you'll see me around during the entire 2 days. Thank you very much. Now I will let our CS-MACH1 project coordinator, Viviana Piermattei, to talk to you a little bit more about the project.
Thank you, Amelie. First of all, for the organization with Nancy and VLIZ, who host the meeting, for all the organization of this wonderful meeting. I will present briefly the project. The project is the CS-MACH1, that is the Marine Citizen Science Data Network. We answer to a call of action because we are looking at an increasing of momentum of the citizen science in Europe, but for sure also globally. And this is important because the citizen science data are a lot and are increasingly important for expanding the scientific knowledge. This is very important because really citizen science data will be an important product and result that will be able to be used for many, many applications by the researchers, by the scientists, and for many, many kind of applications. So the CS-MACH1 sees some challenges related to the citizen science data. First of all, because these are fragmented, they lack fairness and careness, and they need integration. Integration also related to the application, to specific application that can come out from citizen science data. And the other thing is the lack of trust. Sometimes we relate citizen science data to low accuracy, low quality data. And so with the CS-MACH1, what we want to create is something that is more trust on citizen science data, more reliability on citizen science data. So the main objective of the project is to create a network that is based on the three main components of the citizen science data, that are the citizen science initiatives, the cost-efficient and cost-effective technology providers, and the data management experts, that through training, through new improved best practices and fair procedure, can help to transfer all the data coming from citizen science to the science, to the web portal. And one of the bases of this system is EMODnet. Not only this, because CS-MACH1 doesn't want to create another web portal, but want to valorize and capitalize from some of the existing platforms that are the European Citizen Science Platform, the SCOOP platform, the Solution for Cost-Effective Ocean Observation, that is one of the main UN Decade projects within the Cost Predict program, and EMODnet. All this data could be applied to specific applications. So for example, the digital twin of the ocean, and also inside the framework of Cost Predict, could facilitate and democratize the use of technologies to acquire data in the Global South and in areas where the data are not yet acquired. So we tried to do this through this wonderful consortium made by all of these partners that are cover all the expertise required by this project. So the connection, the direct connection to the citizen science initiatives. So we want to look at the existing initiative that can provide new data. To the data managers that will allow us to train and to create new best practices and quality control procedures to be applied to citizen science data, and all the people that can help on this. So the objectives of the CS-MACH1 is to develop this Marine Citizens Data Network. That is what we are going to do these days, is we are trying to put together all the experts or the technology providers, the low-cost technology providers, the data manager, and also the citizen science community to try to do this, to provide new data using cost-efficient technologies and training and improving the best practices. So the final message is follow us, because our project will bring during the project new toolkits, new training, new best practices, new workshop where all the components of this project will be together to try to bring new data to the science, because some of this data will be applied to new application and will help us to arrive, for example, to the digital twin of the ocean applications. So the CS-MACH1 is developed through different actions that have the goal to increase the visibility, the usage, and also the long-term sustainability of Marine Citizens Data Network. And so we will do this through the validation and the demonstration of the data flow. So through the pilots, we will apply all this chain. So we will use existing citizen science initiatives. We will do new deployments of sensor, low-cost sensor, of new methods to acquire citizen science data, trying to face different kind of challenges, from the climate change to the biodiversity loss to the pollution. All this data will be available through these best practices on EMODnet, and will be able to be used and to produce new products. For example, to improve the forecasting system, to also try to co-develop new technologies, because citizen science initiative will help us also to understand the necessities on low-cost sensor, but also on the data management, so from the metadata to the processing of the data to the transfer to EMODnet, and also other kind of application, also to the decision making, for example, for water management, because all this data will be available for the use. And the data of citizen science coming from citizen science initiative for sure will integrate what the traditional data are already acquired, but improving the temporal and the spatial scale of the acquisition of this data. So, for example, one of the applications will be the digital twin of the ocean, because it will put together the observation with the forecasting models and will help us to understand many problems and many processes that we can't with the traditional methods. So this is a summary of the project, and I leave the floor to the next presentation. Thank you.
I think we have a time for a question. Is there any question? No? Anything on the chat, Juan? No? Okay, then we move on.
No, Patrick.
Nice.
We've been doing these things for many years now. I just want to stress the fact that we're really creating the data network, so it's very much focused on the data component. Not to scare anyone away from here, but there are many citizen science networks already around. But for the data component itself, as far as we know, it doesn't really exist. So this is what we're really aiming for creating here right now. Do you want to go for that one?
Yeah, okay. So this is an exercise that we did last time that we met, and it's nice to see that when we think about citizen science, we all several exercises always pointed to the same words. So it's about communities, it's about scientific knowledge, it's about participation. These are the keywords that always pop up in the things. And also, it's very interesting to see that if we ask these people, I mean, if we ask you, and maybe later we do that with Mentimeter, which are the kind of citizen science data that we are collecting, you can see that, again, there are some key topics that are popping up, like biodiversity and some physical parameters. This is also very important and interesting because, as Patrick said, we want to build up on this, we want to build the data flow for this data, we need to think about which is behind in order to organize it the best. And then the other point is also, when we speak about citizen science, we are speaking about participation. So we want to close the loop. So we participate to initiative, but we want also to see how our data has been used. So which is the improvement of the different services on products, Viviana mentioned a couple before, that we can help to improve. And so, again, asking this kind of outcomes, it comes that most of the data that we can produce or we can collect are helping to improve the models or to make scientific publication. So these are the things that we can say. But citizen science, let's also try and be very precise in the definition. This is the definition from the Oxford Dictionary. That was not that, it's quite recent, the definition. And it is the scientific work for example, collecting information that is done by ordinary people without a special qualification in order to help the work of a scientist. That somehow it means that you are participating to a scientific project, although your main activity is not exactly doing research. That is a different way to pose the same concept. And so, as we know, this is a very powerful tool that is growing and growing. The fact that we are here and we have that many people collected remotely, and we want to thank you for participating, it's quite an indicator of this activity. And also the European Commission, again, this was already mentioned by Viviana, it's also betting on the fact that we can use this powerful participatory activity in order to improve some of the data flow that we already have in place. So we need to work on that.
Yeah, you say this community is growing and growing. So we experience that. Either it's growing or we're just getting more aware of what's already out there. Antonio and I got into this, we start looking at it in 2022, I think, where we, under Atlantus umbrella, organized our first workshop on exactly this kind of topic, democratizing ocean observations through low-cost technologies, where we were really focusing a lot on the technology behind it, but pretty soon we got into the connection with citizen science, because these two somehow merge and they fit very well together. So we set up a number of workshops, and they went from 25 people on the American East Coast, and then it moved on, and we got Goose involved. The Global Ocean Observatory System got interested. They helped us up to set up a session in Cape Town, where we moved it more towards the data components of things. And then we went to Genoa for Ocean Race, where we invited how many people?
It was more than 80.
80 people and initiatives to present on their activities and what they're doing. It got to like a peak a little bit late last year with the Ocean Enterprise Initiative. So this is also the Global Ocean Observatory System and others involved in it, with 3 workshops really focused on sensors, the instruments, the platforms, and the market ahead. If you go to the code there, this is where the final report will be available shortly, but you can see all these sessions online on YouTube and so on. A lot of people in this room, a lot of people online contributed to these 3 workshops, and we start building from there. During these workshops, though, and pretty early on, and Viviana, you mentioned solutions for a cost-effective ocean observation platform, Scoop. We realized that there's a gap between the sensor developers and the oceanographic community. So we tried to come up with an idea, how can we get these two to meet? And Emily, you came up with the name of Scoop, and it fits really, really nicely. So we created a catalog of cost-efficient sensors for people who want more cost-efficient, make more cost-efficient ocean observations, a place where they can go and they can look at the marketplace. So it's really like a marketplace for low-cost sensors. It's connecting developers, with citizen scientists, or anyone who wants to collect ocean data. That's the one, Scoop.
And we have some of these people here around.
And they're around.
They're around. So when we speak, going to the point, we had already mentioned some example, because thinking about the sailors that are collecting data while they are racing, that is a very nice example of how we can intend, we can mean citizen science, because you are doing something very different from the scope of the data collection, but you can contribute to the science. So this is what it is about the citizen science. So it's collecting data by citizens when we do other activities, outdoor activity, fishing, racing, sailing, whatever. Projects that are involving communities. We said one key word for citizen science is participatory action. So communities, engagement. Cost-effective sensor, we have already said, because this is also lowering the barriers and the capacity of the people to really do good data collection, especially for some specific field of application. And then we need also to work around the methodology and the resolution of the data. This is also related to the kind of data that we are collecting, because when we speak about citizen science, we are speaking about biodiversity. For example, when we collect pictures, or we do annotation, when we do some scuba diving, and then we annotate, one specific spice or things, or we can make the use of cost-effective sensor, also cheap sensor, but it's more cost-effective sensor. But we are also dealing with some practical and legal, things, matters, because sometimes we have to think about the intellectual properties of the things, data protection. Citizen science is people, so it's personal data, especially if we are geolocalizing the data collection, the information about the collection. Then now we know that artificial intelligence is also working quite a lot on things. So we also need to think about when we make the data available, or we try to extract meaning from the data, the use of these tools. And then, of course, we need also to think about the legality when we do this kind of data collection in different countries, different regions, because we have different laws, and so we need to apply. For example, this is a nice example, because, for example, when we speak about meteorological data, this is considered common means, so everybody is very welcome to collect this data and to share with the neighboring states. But if we are speaking about ocean data, then in order to do some sampling, some research activities, you need to ask the permission to do this. And sometimes, this procedure takes up to 6 months to do that. So it's, we have some, things that we have to keep in mind anyhow when we speak about citizen science. And again, there is also the problem of, why the citizen science data is, somehow the use of citizen science is limited for the time being. And so there is a number of topics that, again, are popping up. For example, the perception about the quality of data, or the verification method, that is exactly the same things, or the methodology, or the data format, and so on. So again, this is coming from an exercise that we did some years ago, because it was during one EMODnet conference 2-3 years ago. So it's important that, progressing. Some of these things have already been tackled, so it's important also to try and update this figure, this picture, and have a new picture. So the aim of this workshop, as already introduced, is really to discuss about the data flow that we can implement via the citizen science action. And of course, we not necessarily need to reach the highest precision, but it's important to provide a consistent data quality and accuracy and the description how we are collecting the data. Because in the end, if we attach this kind of metadata back to the data, we enable the researcher to make the best use of this data, and then we can make knowledge, we can process the data and make knowledge from that. So the scope of the workshop, this is our last slide to introduce the discussion, is to activate and strengthen, this community, this CS-MACH1 community, but it's the citizen science community, in order to implement this co-design workshop and I have some recommendation in order to improve the data management and data flow towards the main stakeholders that we are targeting. We need to work together in order to improve some of the protocols in order to implement the observation or understand which kind of sensor we can apply and when. We need to work on the fairness of the data, so improving the metadata standards. And then, of course, we need to also to close the loop. So we need to align our initiative with some of the requirements that we have from our main stakeholders, that are the European Commission, Marine Data Infrastructure, facilitated interoperability, that somehow comes also by applying the recommendation that we are going to implement. And then, of course, we need also to make some differences between the different domain of application, because as we said, something is taking a picture and discussing about the biodiversity information that we can take from that picture, or if we are collecting physical parameters, that is digital by scratch. So the idea of this one day to a session of workshop is to go through some practical example with, addressing the benefit and the problems that we have in this example in order to help ourselves to better design the different steps of the workflow. And of course, facilitate the exchange of knowledge.
That's good. Done. Yeah. Thank you. We pushed it a bit.
Thank you. Now we'll hand it over to Kate.
I don't know if there is any question, burning question.
No time.
No, we could take one. Yeah. We could take one. One question? Okay.
Okay, Andil from South Africa. Citizen Science Data Workshop is only concentrating to the European Union coastal countries?
No, absolutely not. I mean, of course, we are organizing this workshop here because it's supported by the European Commission, but the general approach and the activity that we are fostering are worldwide. So we really want to implement methodologies that can be applied in all over the world, especially in the developing countries, where the combination of citizen science and cost-effective technologies can be really a boost for the ocean observation.
So no limits, we go global.
No limit. Please, Albert, maybe you use this one.
Good afternoon, everyone. Thanks very much for the invitation from Viviana, Emily, and the team. My name is Kate Larkin. I'm head of secretariat for EMODnet, which is the European Marine Observation and Data Network. We are actually based here. So the secretariat of EMODnet for more than 10 years has been based here in Ostend. We're on floor 1 if you have time during your visit, for those who are in person. And the secretariat is implemented by Seascape Belgium, of which I am a colleague, and we have many colleagues of Seascape Belgium here in the room, either directly involved in EMODnet delivery and or wider projects. And it's a pleasure to be here today to build on the introductions by Viviana and others that really set the context and the scope of the project, and now link it to the bigger picture of what is happening in the marine data landscape in Europe, including the structural long-term data service that is EMODnet. So EMODnet, for those of you who are maybe less familiar of the service, it is a public European marine data service funded by the European Commission. It is a European network and service that I will come on to, but also building on the question we just had about the scope, the geographical coverage. EMODnet covers not only European regional seas, but also the bordering oceans, and more and more global in its remit as well. And the main mandate for EMODnet is to really extract the biggest potential from all of the in situ or the in-water ocean observations that are taken on our coast, in our seas around Europe and beyond, to assemble all of these together and make integrated data layers, data products from more than 68 parameters, in fact, from the marine environment, but also human activities at sea, and to produce these as these harmonized layers that stakeholders can use, for instance, in policy implementation, in environmental impact assessments, and beyond. So we're used by more than 150,000 users per year, and I'll come on to exactly how this is implemented and why it has the relevance for citizen science. Just before I do that, I just wanted to show you, again, if you're not so familiar with EMODnet, what that actually looks like. If you imagine one citizen science project taking a few data points off a coast of a European member state, for example, or from an island state, you can imagine that data is very useful locally for a particular purpose. But once it's shared and can be integrated and harmonized together with thousands of other campaigns that have been taken either by similar stakeholders or in fact very diverse stakeholders, including the private sector, then you start seeing the value of bringing all these data together and the power of not only the data visualizations, but the resolution, the coverage that you can get from all of this. And it's really driven as a service, but also implemented by a very diverse and expert network. So EMODnet is a very unique network in the sense that it has 133 partners, 33 countries, of which 21 are EU member states. But behind that, there's a whole pyramid and a foundation of all of the data provision into EMODnet, which is thousands of campaigns, more than 600 data aggregators, working with national oceanographic data centers, geological surveys, hydrographic offices, etc. But we more and more have NGOs, citizen science initiatives that are either providing data or using data and even becoming funded partners as well. Here I also put a recent workshop we did last year with the team from the secretariat together with the data ingestion and the EMODnet thematics, where we brought together blue NGOs, so ocean-related NGOs in Europe and beyond, with citizen science projects to really take a look at how they could leverage EMODnet for their own benefit. And I hope that some of those stakeholders are joining us online and perhaps even in the room today. The network, as I said, here we are at the Open Conference that happened in just the end of last year, and that really gave us a lot of momentum going forward, which I will come on to. But in a nutshell, in terms of the link with citizen science, EMODnet already has many different links with citizen science. All of the thematics at different levels are engaged with citizen science. We are increasingly approached by citizen science projects looking for a place to bring their in situ marine data. And as you saw from the project scope of CS-MACH1, there is a direct link with EMODnet, where EMODnet experts are partners in this project and will be helping to co-create these guidelines for managing the data, the metadata from citizen science, together with the citizen science projects and data collectors themselves, because that's what will make it so powerful, that we co-design it so that it works for you, but that it's also optimized, ready to go into these data services. I won't go through all of these, but it just shows you some examples from EMODnet biology, physics, and chemistry, in fact, the diversity of citizen science projects, from marine cetaceans in Italy to the ocean race that was mentioned, and to marine litter in the Black Sea region. There are many initiatives ongoing and links with EMODnet. And then what does the future look like in terms of EMODnet and also EMODnet citizen science? So the community launched a vision document end of last year, which is available publicly, and we have some printed copies as well, but it's available online. And this really set the scene, the recommendations for the next 10 years of EMODnet. And it had 4 dimensions of value for EMODnet across its value chain, connecting directly with the ocean observations under the collect domain, all the way through to the user applications and the European digital twin policy, etc. And there are lots of connections now that we can take forward together with CS-MACH1. The main overview is that EMODnet as a community wants to scale and diversify its data sharing, but also its service offer. And we really need that partnership with citizen science to make that happen, to fill gaps in the existing professional system, if you like, of the operational oceanography, but also to then bring citizens right into the data collection and the funding process. So we see the partnership with CS-MACH1 really as a win-win for this, and also in EMODnet's recommendation to become the European Union's focal point or hub for in situ marine science data.
Kate?
Great. My very last slide, and I will click through this without going through the text, sorry for the reformatting, was that the endpoint of all EMODnet's data is not only on its portal, but available now on the cloud through the European Digital Twin, which EMODnet does together with Copernicus. So you'll hear much more, I'm sure, in the coming days. Thank you.
So we're going to now start with Icebreaker Menti session. So it's time to take off your phone or to do it from your computer. In the room, of course, and of course also online. And then I will let Siggy and his two co-moderator to
All right.
do the Menti.
Do our job?
Yes.
Okay. We'll do our job. Good afternoon, everybody. My name is Siggy Kluckner. I work for IEEE France section, normally focused on best practices. Today, looking at getting you a little bit more engaged. And this is both online and here in the room. No worries, you don't have to do any jumping jacks. You don't have to get up. We're going to exercise your thumbs. If we could switch to the Mentimeter, that would be great. There you go. So please, everybody, get out your phones, scan this, or type in the code 39957149 in Menti. And then we'll wait for a moment. And oh, it looks good in here. Everybody's ready. Look at that. Good priming, Emily.
Yeah, I try. Thank you.
All right. We got a lot of thumbs up as well.
Oh, yeah.
Okay, so what we want from you to do is we want to get to know you. We are interested in hearing on what you do, who you are, where you're from, and so on. And we'll start with an easy one. Please tell us your email address. So the first question that we have for you guys is, which categories of citizen sciences are you a part of? And we have the choices of initiative manager, developer, device developer, researcher, or data user, or data manager. And I will leave it to my two fellow panelists here to interpret that. But it looks...
Thank you, Siggy. Let's wait a bit.
Yeah, maybe we can add a couple of words while we are asking these categories, because as we said, we are trying to design better the different steps of the workflow for the data delivery into the European marine data integrators and stakeholders. And so it's important to us to understand which is the, let's say, knowledge and expertise of the people that we are dealing with. So knowing that we have, for example, data manager, then of course we can address some specific question, or we can do some specific job together, because of course he knows some things that we already need. While it's also important to understand if we have device developer in the community, because maybe they want to push for the technology because they know that it's brilliant and good, but somehow it cannot be uptaken to a certain level because they are missing this connection point with some people that can digest their data.
If we now look at the feedback, it's really nice to see over 100 people online. I think some were somehow to be expected. We have a equal division almost between citizen science initiative managers and the researchers, which are the largest communities, I think, involved in the citizen science. Device developers are the least, but as Antonio explained, really fundamental also to be involved more and more. And what I'm very happy to see is that we have a lot of data managers, because CS-MACH1 and this event also especially, we focus on the data component and the data flows, optimizing the data flows from the citizen science initiatives. Yeah, and what's better than already having so many of the data managers involved, so great.
All right, it looks like a really good diagram, doesn't it? Like well balanced. All right, I think we're good. We have, almost 100% response rate there. Let's keep this up. So where is your citizen science activity taking place? It's not necessarily where you live or where you dial in from, but you have a variety of countries or regions, whatever you want to add in there. We'll go into a little bit more detail in the next question. So wherever you are working with the citizen science projects, that will be really interesting to know. And look at that. This is
all over the place.
This is
We
really
can
all
already
over the
conclude
place.
we're global, right?
This is definitely a global network.
Yes, and this is good because it's also answering the question that we were asked before. What are we aiming to? We are aiming at to go global, because I mean the challenges, or well, actually the reasoning that we are trying to achieve with this workshop, it's really to try and facilitate the activity of the different citizen initiative. And so if we can facilitate the data flow, or supporting the developers to facilitate data flow for the data manager and contribute to marine data integrators and global programs, then we have done a very good job.
Yeah, you can see some of the European countries, of course, having the overhand, but in general, we can say pan-European and way beyond. So
Wait, goes
thanks all for joining, also in the different time
Yeah,
zones.
I know.
Probably
This goes from Bangladesh to South Africa to Canada. Like, this is pretty earth spanning, isn't it? All right, we'll give it a few more seconds, and then
It will be very fun to, play with this information once we have all the answers. Because here, for example, I'm already guessing something about the thing. Because when you see cities, for example, then usually it's something that is more biodiversity related than when you see, wider areas, then probably the cost-effective sensors are taking a major role in that kind of projects. But we will see.
wow, still going. All right. Okay. Well, the next question, I'll leave this up for a second for people to finish typing. The next question will be the geographic scale. So here, what is the scope of the activity? And I mean, this will partly overlap with the last one. But of course, when I see it local being like sub-regional area within a certain area of a country, national, focusing on one specific country, regional is over different countries, and international. I mean, we saw global and we saw pan-European that probably would go into regional. But it looks like that we have a lot of international projects also going on, which is also very helpful and adds its own challenges, doesn't it?
yes, but also they could have global impact, right? So
Yeah, exactly.
yeah, and all are equally interesting to dive into, because with the local ones, you want to see how you can improve their data flow so that it reaches better their national reuse and also European level. Well, the same for the other. So we are very equally divided, I see.
Yeah, that is very interesting. And by the way, also, this is also really in line with the scope of the workshop, because one goal is also to identify some best practices that can be applied or transferred to other places. So if we think about local, for example, one thing that has been worked very well in a city can be also in others, as well as, let's say, scale up in terms of the geographical scope. Something that is local maybe has already the fundamental to be pan-European, or they can easily uptake some of the suggestions from the international activities and became international as well.
Right. Yeah, that's the great thing. I'll be talking about best practices later, so.
Stay tuned.
We have 5 minutes left. I think we're talking too much. This is too exciting, isn't it? Here's a question. What is the most exciting part of marine citizen science for you? And we want to know just how excited you are. What is the cool things that you're doing about this? Where does your heart start beating when you think about the projects that you're doing? Like, why is this so important? Why is it exciting? And
this is, again, collaboration engagement. They are really top scored.
I mean, and most of it is a voluntary action, so people actually do it not for the money, right? So, or a lot of it is. There is some ulterior motive behind it than only money, I hope.
That is a very good point, because I mean, in the end, it's the willingness of collaborating and participating to science. So be engaged, be part of something that is bigger than us, helping understanding. I mean, we are also facing, climate changes. So we know that our little action can contribute to better understanding some specific issues that we may have in our local region. And then by doing that, then you also have the opportunity to meet nice people. So
That's it.
thanks
That's
again
it.
to all the people that are joining, and also visit exotic place, because when you do an international collaboration on citizen science, then you can also take the opportunity to join something that is interesting but also fun.
I tried to read also the small ones, but they
Yeah,
changing.
they keep jumping away.
But yeah,
Oh,
you can
there's
see
massive data
the
collection.
common denominator.
New
education.
findings. I mean, this is great for us to know how we also can, what we can do in the workshop and what items we can approach. All right. Now a quick one. Which marine research disciplines does your activity cover?
Your
do it
bets,
very
please. I'm betting biology, biodiversity.
me too. Me too.
Let's make some bet.
Don't bias.
Usually it's the
But
winner.
go litter.
Later, yeah.
All right. We're trying to be fast.
Yeah, we're halfway in the responses. But we can already see the trend. It's we knew from previous exercises that biodiversity is the largest community, but I see that online at least we also have many litter, which is good, because tomorrow we have also a dedicated session on litter and what we foresee to provide a support for the litter to better reach, as Kate just presented the uptake into EMODnet. There are already some cases where it works, but
All right.
and also physics, Antonio, good for you.
I was saying, sorry for the ficus, we have to cut the session tomorrow because there are other. I'm kidding. No, it's good that we see also a lot of physics there.
Yeah, no, tomorrow we have three cases on the where we do sample cases about physics, biodiversity, biology, and litter.
Yeah.
And
There you go.
so we will look into it. Yep.
We did a
All right.
good guess.
Well, you know your audience, don't you? All right. We have 1 minute left, but I have 2 more questions, and those are important, or maybe more. Expectations from this workshop, and we'll do a quick 20-second answers, please. Or no one has any expectations, then this is also fine. I guess they came because... All right, look, the names don't show up. That's the...
Yeah, but this takes a little bit of thinking. So,
I know.
yeah.
I mean, you're more than welcome to also come back to us on that and tell us in person.
Is it the last question?
We have another one.
You have 52 seconds.
Expectations on networking, very good, because this is really the, I won't call it the start of the network, but definitely a kind of an escalator, or how you call it.
Also here,
Guess
see
we'll-
some
We bring the network together
yeah,
to these
some
days.
common trends, best practice. that
Best
is
practices
also
you can definitely expect from CS-MACH1.
having a good methodology to apply and to
You know what?
follow.
In the breaks, we can also slowly go through these again. If somebody else wants to add something, we can also go back to them and add more information if that is if it's if we're too fast for people right now.
Yeah. Maybe for this one, yes.
Because we do have 2 more questions. The expectations from the network, which we can also discuss later on, but I want to give you the chance to respond quickly. Because we do have one really important aspect on the support and training that we do want to have in a discussion.
Yeah.
And also thinking about, some of the answers that we saw before, learning also, so training, sharing, again, knowledge is part of the ambition that we are setting in this project. And again, finding also ready available good practices. It's a way to us to facilitate also this knowledge transfer. So we can implement the training materials, let's say like that, on top of other expertise and experiences.
All right, get my data used. That's a good one.
Yeah.
Good one. Enhanced data flow mechanisms, huh? Right on topic. Yeah.
All right.
I think we can try to see if we can take the two questions maybe at the discussion.
Switch to this one here, because I think that's one of the most important ones. I will we will try and circle through them. If you leave the Menti open, you can still add to the different questions, but this one I think is important. This is a ranking, if I am not mistaken, so you'll have to like move those things around on what is most important for you, what is the most important support that you would need for your citizen science initiative. Yes.
Who is you in this?
These citizen science projects. I mean, if we do have researchers in here as well that have those challenges, then feel free to add them, as long as they have a relationship to citizen science projects.
And also this is almost in line with previous exercise. So again, the topic of facilitating or having tools to do data validation and quality checks and facilitate data interoperability are key topics for all the people that are participating to this workshop. So this is something that we are addressing with the project, so good.
Yeah. Yeah, and I can imagine also citizen engagement could be a very important one, but it's not necessarily the topic of the CS-MACH1 network.
But this is, I would say that probably if you can prove that you have a very good data workflow that is also including the validation, the interoperability, the use of this data by key stakeholders, then engagement is easier because you can somehow sell this concept as part of the activity that you're developing.
Okay.
All right.
Right.
So this was our last question for this session. What I wanted to mention, and I think I mentioned it before, we will have the Menti open all day. And what we are also trying to do is that for each of the speakers that you will see here, we have a Menti question open where you can submit questions, comments, feedback, everything that you wanted to tell that person. So that helps us also to collect that information directly to that presentation. And of course, also we can allow the presenter to come back to you specifically on that question. So keep the Menti open in your phone or wherever you're doing this, and you will see a lot of questions that come up every time a new speaker comes on stage. All right. Well, thank you. Thank you so much. And
thank you.
Handing over.
Maybe.
Yes.
This is working.
Let's go for it. Okay, let's just bounce into the next session here, where we're going to get some short pitches. You guys, you can hang around for a while, Peter. We're going to hear about FAIR data. That's already been mentioned here earlier today. We're going to hear from Antonio on connecting citizen science oceans physics data and Ziggy, ocean best practices. But first one out, Peter.
Yeah, good afternoon, everyone. Yeah, you saw me already on stage. My name is Peter Thijsse. I'm from Maris in the Netherlands. Small SME working on marine data use and reuse and optimizing that in the best possible way. So that is also our role in CS-MACH1 and beyond in other projects and programs. And at the moment, for this presentation, I want to focus on one of our goals. It's working towards fair citizen science, data and metadata. And it's actually bridging a bit between various other presentations that you've seen. And just want to bring us all on the same page and provide you insight in where we want to take it with CS-MACH1. So I will go through the marine observation data landscape. Fair metadata and data. I'm not going through the whole fairness, but at least to indicate where we want to take it and what we see as important. The marine citizen science data landscape, how that fits in, and shortly what we will offer. And that's linked also to the comments we just made to the Menti. Yeah, this I reuse that many times. It's because it's a very nice overview of what's going on in the oceans and the seas, with a lot of observations, and in a very old, I think, actually it's already more than 10 years old, right? At 1.4 billion euros spent on observations in Europe. I think with inflation, yeah, it should be above 2 billion, I think now. I'm not sure. I've never seen an update, but it's a lot. And yeah, you wouldn't believe it, but even though it's so heavily observed, there are still gaps in space and in time and in distribution, and also on the coast. And where are the citizens? Well, usually in the coastal zone and in the deltas and fishing, sailing. So yeah, that makes it can really provide have a very strong impact in filling these gaps by already ongoing initiatives, collecting biodiversity information, making use of all kinds of cost-efficient sensors, a do-it-yourself CTD, or sticking a sensor on the rocks, or doing counts underwater, or bringing your dive watch below and, well, observing without knowing it, because you do it anyway. And, well, combining all that. And we want to offer that support to really make sure that all that data that is already being collected and can be even more collected, that it actually reaches the end users. And how does it work now? And if you see the diagram on the right, it's also a little bit older, but it still works. From the bottom, you see the data being collected. I don't know if the camera follows me. The microphone does not. There's the data collected. It reaches the first use usually, if it's a traditional observation data in the country or in the research organization. But for reuse, you need to make sure that it fits to international standards, so it can be exchanged. And we have in Europe, we have Eurobis for biodiversity data, CDataNet for delayed mode. We have EMODnet for the physical data and other data flows, and it aggregates that and brings it up to nowadays Edito and other EOSC, the European Science Cloud, and global reuse to all kinds of end users. The key in that is to make sure that all that data is as much as possible fair, findable, accessible, interoperable, and reusable, and that actually needs to start from the basis when you collect it, so also from citizen science data. So what is fair? Well, findable, accessible, interoperable, reusable, and it's a movement. And we're constantly striving to improve it more and more, and it's actually aimed at accessibility for machines. For humans it's nice, they can interpret, but for machines it's even more important. And that has to do with that there's more and more processing, modeling, virtual research, where people want to code against data collections. So there's a growing need for data, a growing availability, but we need to make sure that it fits. So yeah, I'm not going through all these, but these are the fair metrics. How can you determine if you are fair? Do you have placed your data in the right spot to make it findable and accessible with the right type of metadata? And then the most important ones are interoperable. And that has to do with vocabularies and the right metadata, descriptional data about the data observed. And reusability, that's the biggest challenge, because for that you need to know in the end, if you are a user and you don't know anything about the initiative, what sensor was used, where was it collected? It's really basic, but also how was the sensor deployed? Because otherwise you do not have the right level of trust to reuse it. Yeah, and that's the holy grail. If we really want data to reach all these products, like in EMODnet that you saw in Kate's presentation, or in other models, or reuse into Edito, we need to make sure that we can trust this data. So yeah, just a flavor. registration, we need to make sure that it reaches at least known repositories. Zenodo is a very important one for data as is. EMODnet and Eurobis and CDataNet. Well, via that it will reach EMODnet. For accessibility, we need identifiers. Publish it, open metadata. For interoperability, we need to make use of standardized vocabularies. So not write in text, this is temperature in the water. No, it needs a code, because that code is interpretable by a machine, and you're absolutely sure that it's that, even though you don't know nothing about how it was deployed. And the same with reuse, as I said, all kinds of parameters about deployment, a link to the sensor that was used, or the sensor type. The more you know, the more trust. Tomorrow in the presentations, we have three sessions about physics, biodiversity, and litter, and there we go a little bit more into detail about this. What we actually understand about it. And you can expect that CS-MACH1 deliver, well, first of all, we will build a community, as we're doing now. Bring the experts, the data experts, marine data experts, the researchers, the data managers, and the citizen science initiatives together, and the sensor developers. We will deliver best practices and recommendations for metadata and how can you improve your metadata, all focused on this compliance to fairness. We'll recommend vocabularies to use, so standardized code list in certain fields, deployment and observation protocols, and for litter observation, for example. If you don't follow the right protocol, it's really difficult to combine it in other data sets. And yeah, this is all discipline dependent. So we will provide discipline example cases. We will start tomorrow and we will document that and thematically make that available to all the users in webinars and training. That's it.
Thanks, Peter.
I mean, just following the structure that also Peter adopted. Here we are going to see which are the ocean physics parameters, why we are collecting this data, how we can collect this data, and which are the main tools we have in order to discover this data. And this was already addressed, if we have enough data, how it works, and which are the tools that we can already have in order to implement these workflows. So what's the ocean physics? Which parameters we need to collect and why? Ocean physics is the study of the ocean, the physical processes governing the ocean. So we speak about how the ocean moves, how it mixes, how it exchanges energy. So there are many topics. So it means that we need to address processes like heat transport or circulation, tides, waves, but also the interfaces are quite important. Here I mentioned the air-sea ice interaction, but of course also the coast ocean interface is quite important. If you speak about litter and we speak about the litter coming from the rivers, that is a really important and hot topic. We speak about temperature, salinity, sea level, currents, waves, and so on. So we have quite a huge number of parameters that can be collected in order to implement and analyze and process this data information. And some of these are combined together in order to offer the essential ocean variables. And these are usually related to scientific issues and societal benefit. Here I have a nice animation, because usually when we need to address a topic, we address a topic that is related to scientific issue or societal benefits. So for example, climate adaptation, marine safety are key issues that we need to address. But how we can do that? We need to collect data and provide this information to services that are addressing this topic. So if you have parameters, then you can, according to the parameters, you can address different scientific issues. But if we want to be closer to our life, we can also address easy questions. So, do I need to wear a swimsuit in order to go swimming? Or are they good waves for surfing? These are also part of questions that we need to address, and we need services and data in order to answer. So how do we collect in situ ocean physics? We are using a quite huge number of platforms that are quite expensive. So here you have a nice picture that I took from the Copernicus Marine Service that is presenting the different platforms and type of data that can be collected. You have profiling boats, you have mammals that are equipped with sensors, you have ships, you have coastal platforms that are collecting, for example, currents or the sea level and so on. So we have quite huge number of data. And where can we find this data? How can we access this data? We have already mentioned EMODnet. EMODnet is the European Marine Observation Data Network, and EMODnet has, the different thematic lots as Kate presented. Under physics, you can find all the ocean physics information. So physics section in EMODnet is collecting and providing access to the whole physical parameters collected by fixed station and moving platforms. One key and important thing is that all the data are open access, so they usually comes with a CC BY license or similar, and this is also quite important because EMODnet is broadcasting this information, so we need to access and have the permission to republish this data. And of course they are fair, and we are discussing about that. EMODnet is building on top of marine data infrastructure and program initiative, and of course those standards and best practices. So this means that in order to have data into EMODnet and physics, we need to follow some standards and best practices. So that's why it's so important, some of the topics that Peter already mentioned. But of course, as we are speaking about millions of data, we need to also implement automatic machinery tools in order to facilitate this. So we need fairness also for machine-to-machine interoperability, so we need to develop APIs. But how much data do we really have? This is an animation that I made on top of the data that we have in EMODnet physics. Each dot is representing one, if in that specific place we collected at least one data set during that specific year, because each slide is 1 year. So you can see that we have a number of gaps. So we have data, but we are really missing a lot of data. So that's why citizen science and participatory action can really contribute, because we have gaps. And so this is, actually is a comics that I made from a real case, because I had a friend of mine that is diving and is really keen to support scientific activity. So he asked me, how can I contribute? So I told him, wear a sensor when you do diving, so we can see the outcome of the data. And so then time by time, he started doing that, and actually it was interesting because he also raised some, challenges or some discussion topics, because it happened that he was collecting a very warm temperature one day, and so he asked how he could check if it was okay or it was wrong, the data that he was collecting. So I told him, if we are able to facilitate this data flow into a platform like EMODnet, then you can, you can check yourself. But in order to do that, we need to do many steps, because we need to be sure that metadata is properly filled. We need to verify the quality of the data and so on. But if it works, then it's cool, and then we can also have further engagement of the city, of the citizen science. And of course, if we do all these steps, then it really means that our data is fair, because if we can find this data on top of EMODnet, it means that we accomplished all the different steps that we are addressing. But do we have tools to do that? Yes, we already have some tools. Are they covering all the steps? Not properly. So part of the workshop that we are organizing is also to find some of these gaps and try to address concrete action in order to solve some steps and have more data flowing into the system. So we have tools, yes, some have already been mentioned by Peter. So we have the vocabulary service that is quite important, because it really helps us to understand, to have a common language on the data usage. We have tools, software tools that can facilitate the interoperability. Peter already mentioned Zenoto, the community, that are very powerful for doing that. But we also have other tools like AirDAP, that is a software that is facilitating the data manipulation. But also we have tools that are helping us to do online or cloud-based processing. And again, we are speaking about tools that can be deployed on EOSC, but you have also, complementary and open tools that do not need to be a scientist to use them if you have good templates. But is fair enough? No, it's not enough, because this is a nice example. Patrick participated in this exercise. They they sticked some sensor on top of paddles and surfs, and they collected some data. But as you can see, we need to clean a bit of the data, because you see the temperature from each color is a different sensor. So you see peaks, and we need to really focus on the specific part that was collected while the paddles, the loads were on the sea. But also inside them, you see that there are some driftings, because one sensor was somehow biased. So we need to have tools that help us to clean, some of the data that we are collecting. But this is another example, because we have, Frank here that was supporting us in order to implement this data flow. So we are already receiving thousands of profiles from divers. These data are already available in EMODnet as is, so we can find them. You can already download this data from ERDAP, this tool. But when you play a bit with the data, you see that you have, strings that are offering this information, let's say, not an easy way, because we have one string that is offering the depth, one string that is offering the temperature. So we need to have tools that are reshuffling this information and provide you with, the full profile. That is the minimum information that we need to use in order to be plugged into the system. So let's work together to map tools and technologies. Peter already mentioned that tomorrow we are going to have a dedicated session. And so please help us. You are ready. I want to thank you again for the nice participation. So help us with the filling with the Mentimeter that we are doing. If we have tools, please share. Let us know which tools you can provide, because this CS-MACH1 is also, let's say, a place where we can facilitate the community to find tools and sensor and all the things. And then, of course, please share your data, because if we have data, then we can work on that. And that's it. Thank you very much.
Thanks, Antonio. Thanks a lot. I'm rushing this a bit. Yeah, I can tell. Siggy, welcome back up on the stage to tell us about the ocean best practices.
I'm rushing as well. Public service announcement for those online. We are working on the resolution. Also, we are circling the Menti later so that you can add more things. You don't have to duplicate them. When you already answered, don't worry about it. Just to give you more time. All right, switching gears. I am here to talk about ocean practices for marine citizen science. Pretty much starting with something completely different. How many people here know a French press? All right. Do you know the official rule to make French press and what do you need for it? Officially, one of the suggested things is that these are all the utilities that you need for making a French press, including, for example, a thermometer. I don't do that way. I just cook my water and hope it's the right temperature, right? And this is the step-by-step guide on how to do a French press coffee, including, which I have not done, cleaning it right after use. My coffee pot stands around for a few hours until I get to it once I had my coffee, because I normally get distracted on doing something else. But in here you will see a whole bunch of, if you read it very carefully, you will see a whole bunch of things that are questionable. Somewhere it says Fahrenheit, but we are in Europe, so maybe we shouldn't, do that. There it says 200 Fahrenheit. It's up there somewhere. It says 3 to 5 minutes of letting it stay in there. Now, what is it? 3, 4, or 5, or is it 3.5? We don't know. But so this is what we consider a practice. It might be a good practice. It might be the one that is suggested by the producers of the French press. Not everybody does it that way, but it's the suggested way to do it from that website, whatever it is. I do it a little bit different. Mine works well. My coffee still smells good and tastes good. Why do I telling you this? Why am I telling you this? Because this is a practice. A practice is how something is done. It's as easy as that. In transferring this to the ocean science, of course, or the ocean observation world, it's a documented method that contributes to the collection, analysis, sharing, or application of ocean data knowledge. So it's everything that we know how to do, that we document it so others can as well use it and reuse it and potentially also improve on it. So I'm doing my coffee with 4 minutes, by the way. Good measure. So really that means that a practice can be anything from a method, a procedure, any approach used, can be a standards operating procedure, can be manuals that people are writing, guidelines, but also you can use standards as a practice, right? So if there is a standard, then technically that's also a practice that people follow and stuff how they do it. Or even training materials. Anything that you find on OTGA might be something that is a practice because it shows you step by step on how to do something. A best practice, you might have seen Jay present this before, is a methodology that has repeatedly produced superior results relative to other methodologies with the same objective, right? So over and over again, we apply a practice, we see that it works better than what my neighbor's doing, espresso machine and all. The maturity of a practice here, through 1 through 5, really quickly. 1 is I do something, I formed a practice. Number 2, I repeat it, it is repeatable, great, I have a repeatable practice. Maturity level 3 is it's defined and documented. So it's really formally documented, it's openly available, and it's replicated by an expert. It can be replicated by an expert. So not everybody needs to be able to do it, but if I know the tools and the measurements that I have to take towards this, or if there's any specificities in there from my field, I can replace it, reproduce it. Oh, there you go. Level 4, a broadly adopted method, is then already used by multiple institutions. There are means to verify the implementation. Guidelines for evolutions are there, so what needs to be done or can be done so that it can get better, and we have standardized formats included. And the best practice is one that is endorsed by an expert panel, so there are people who look at this and are like, yes, this is really good. This is the best thing that is out there currently. We have provisions for training in there and so on, so you can read that here. I have 3 examples really quickly that we found in the OBPS for marine citizen science. This means you can go look it up. There are 3 ones that I found them really appealing as well. So one for the collecting citizen observations on non-indigenous species. It's a very practical example. It shows what do you have to do, what do you have to consider. The second one is evaluating citizen science project descriptions. So they also offer a template. The authors offer a template on how citizen science projects can be described so that they are more appealing. It comes more from the science communications perspective, but it can be also, and it is a practice for citizen science to explain what you're doing to the citizens that you hope that you are engaging. And the third one is per se not a citizen science practice, but it is a methodology for documenting the biodiversity of algae and invertebrates on rocky coasts. And this is really showing how to take photos of a coast that are then submitted into a repository. And they have a very, very clear and great 18-page with photos documentation how to do this so that a lot of people can do that, and they are trying to do this from pole to pole in the Americas. It's really interesting to see how they have set that up. For those who don't know, finding practices, right now we are expanding the infrastructure a little bit, if you want to say that. So you have the OBPS, which is now an IOC program, which is pretty broad. I think we have over 2,000 practices stored in there. Covers a lot of issues that are also broader than only ocean observation. And we have the EC OBPSS, so the European Commission's Ocean Best Practices and Standards System, I think, that focuses on observations mostly, and it has the maturity level of only 4 and 5 that are hosted on there. So this is, I think, a big difference. Also, Antonio can say a lot about this as we're working with him on that, right? So OBPS itself also provides standardized document templates, and we have one for marine citizen science that is currently being developed and under community review. So this would help if anybody has a practice that they think this would be great, that others can benefit from it, that others can create something along those lines. We can use the template so that the structure of the practice is also somewhat comparable. And that's my short pitch for we need more practices documented. If you have any questions, please reach out to me or my colleague Laura, who is online and also working the Menti with me. Please do submit anything on Mentimeter, and I think now it's time for
The break.
the Finnish
The
coffee.
French press.
Well, we have it easier out there. The practice for out there is press a button.
Emily, over to you.
Okay, thanks a lot. Then thank you for this session. As Siggy mentioned, we will work now during the break on trying to fix the resolution for the broadcasting online. Also, be on time. We have 10 minutes.
Let's start again. So, session on biodiversity. The last session called short pitches and had 10 minutes. Now we have very short pitches, 5 minutes only. So I will not introduce any of the speakers. There are 4 of them. Just come in front here, start your presentation, try to keep to the 5 minutes, and then afterwards we will have some questions. The floor is yours.
Perfect. So I'm here to introduce you to all to EMODnet biology. As we noticed with the presentation of Kate, presenting EMODnet can be quite time-consuming, and since we are limited on time, I will skip this slide and directly dive into the specification of EMODnet biology. So for EMODnet biology, we mainly focus on European Sea, but we still accept data from our fellow researchers that gather data from anywhere in the world ocean. Concerning the data content, we mainly target nice swim teams, as you can see in the slide. And we have various data types like observation data, acoustic, tracking, or imaging. And lately we were receiving genomics data by our providers. The motto of our project is collect once, use many times. That highlights the importance of following the standards and like the FAIR principle. So that's why we will insist on following the different standards that exist that allows to make the data as interoperable as possible and then make them as understandable and usable by anyone, even machines. EMODnet biology started by being built on the infrastructure of Eurobis, and it started in 2009 with 50 data sets and 1 million occurrence record. And by today, right now, we have more than 1,400 data sets with more than 42 occurrence records. So it's quite a big grown, and we don't plan on stopping there. So I hope to see as many of possible of your data in the near future. Apart from collecting data, I would like also to highlight the initiative that we make to reach as many people as possible. So we organize biological data management training, but also some networking event like hackathon. And finally, also we have X account if you want to follow more on the ingestion of our data. Last but not least, we also do our own analyze of our data to find the gap analysis that we have. So if you have data about subteams that are here that are lacking, don't hesitate to reach out to us. And finally, I would like also to highlight the team behind EMODnet biology that is working here at VLIZ. And that's it for me.
Oh, that's perfect.
I bring my timer. Okay, I'm Dave Wall from National Biodiversity Data Centre for Ireland. So we do what it says in the tin, collect, collate and make available biodiversity data, not just marine, but terrestrial and freshwater as well. One of the things, I suppose I'm here, firstly, as a citizen science project manager, but also as a data manager. So we have responsibility for both. We get our data from multiple sources, but we also generate data through citizen science projects that we run. Our home on the interweb is biodiversityireland.ie. I'm here just to give you an overview of how data flows work in one of our citizen science projects, Explore Your Shore, which was set up in 2019 to look at intertidal marine biodiversity data. We run a number of surveys, casual effort, rocky shore, beach survey, and rock pool surveys. We collect the kind of data you'd expect us to collect, which is date and location, species abundance, whether the thing is alive or dead, and a photo, which we insist on. So these are our kind of minimum data standards for a record. So far to date, we've collected and validated about 28,000, 29,000 records across 800 odd species, with participation around 2,000, 2,500 people. So if we look at what happens to the data as we collect it, it comes in through an app. The app is in red because our app kind of struggles a bit with modern technology. Apps are like babies. They require constant attention and feeding and nourishment and money. So they can be problematic. So it can be one link in your many chains of where issues can arise. But we also have a web form, and this is how a lot of people record the data through an online web form. And they follow that minimum data standard, and as I say, each record is accompanied by a photo. When they log in then as citizen science volunteers, they have a citizen science portal, which is a variety of data tools, which enables them explore their own data and compare it to other data that's coming in through the same project. We move on then to a validation process. We do as much data validation in-house, but there's a lot of marine species, so we can't do everything. For those unusual and niche groups like polychaetes and sea spiders, we use external experts and get those data validated that way. Capacity is a big issue for data validation, particularly for niche groups where we don't get many records and there aren't that many taxonomic experts available. So we're always on the hunt for more taxonomists, and I think you'll hear that cry across Europe in all sections when it comes to biodiversity. Once validated, the data is output onto biodiversity maps, and this is really our interface for end users, where they can view what data is available. They can view the metadata for each data set to give them the information on how it was collected, who collected it, etc. We have a nice mapping system which shows you, you can search by data set or you can search by species and see how many different data sets are contributing data on that given species. From there, you can either download it if it's open access, or you can find the data owner and go and ask them for permission to use it. We output then from there onto GBIF. The National Biodiversity Data Centre is the Irish node for GBIF. And then from GBIF, in theory, we export to Eurobus. Now, we haven't done in some time due to technical back-end issues, but we have, Cyril, I hope, I'm looking at you. We have fixed this issue, so update will occur very soon. And so it goes from GBIF to Eurobus, and that's the way the data flows out from there. And then we encourage people to access and download that data from there if necessary. So tech issues aside, if we can get through there, everyone has access to the open access data anyway in a Darwin core format. Okay.
Okay, and for 5 minutes I will be Nancy Fokkerday. She's sick, but I have to replace her. So talking on the application minca.vliz.be, working actually with two citizen science projects along the Belgian coast. Well, first maybe introduce Nancy. For those who don't know her, she's a marine biologist by training, working in the science communication department at VLIZ. And one of the projects that I would like to put forward is SeaWatch-B. It's a monitoring project of the Belgian beach and surf water, a multi-parameter monitoring project started in 2014. You see that we have almost 500 surveys now, collected by about 40 citizens, so it's rather small in number of participants, but it gives very interesting data. And then we have a second a one-day event. It's called the Big Annual Seashell Survey. It's actually one of the parameters from Sea-Watch, looking at relative abundances of seashells, counting 100 shells and identifying them at random. And this is also a quite successful thing. We started in Belgium in 2018. The Netherlands adopted the program, now also have their seashell survey. Northern France is starting, Scotland has plans, so if you are willing to participate or joining us, let it know. We've been counting, together with the Netherlands, more than 500,000 shells, so we learn a lot, of course, on a stretch of 400 kilometers of beaches. Okay, so but yeah, we with SeaWatch-B, so the full program with the 15 parameters you see on the right. The last 5 of them are optional. The other ones are, well, they have to carry them out. They are all standardized, and they work along the Belgian coast. We are lucky with our Belgian coast that there is only 65 kilometers. So with 20 stations, you have a very high density of data, so that helps. Also, beaches are very easy to access. We provide them with all kind of easy tools that they need to do the work. We provide training. We give very immediate feedback. That's crucial. They work a lot also with photographs to make sure that biodiversity measurements, but also we work on litter and temperature and other things, that they are all done in a nice way that is comparable. Okay, so just to show you one of, or 3 of them, we look at groins and limpets growing on this hard substrate using this kind of quadrants so that you have densities at the end. We allow them also to do some shrimp beam trolling in the surf zone, so they catch crustaceans and fish and other animals, again in a standardized way because they walk 100 meters to meters wide. They identify everything, take pictures, measure the fish, and so on. But they also look at, for instance, lugworms on the beach, and many other things. So it's maybe rather unique in being having so many parameters that we use and standardizing everything. In terms of the data flow, actually, we started in a more primitive way, a very basic way, I would say. In the beginning, it was like sending reports in Word or Excel, sending the photos with retransfer. We collected everything. We did the feedback and the quality control, and then had to do the input in the data system, which is, of course, a bit stupid and primitive. Anyhow, we managed to send the first amount of data of the first 4 years of this program to EMODnet and GBIF. But of course, we learned that this is not feasible for the future, and with some internal money funds we could get, we produced a web-based data platform, actually something that is derived from the Minka platform produced by CSIC and Quanta Labs. So we had a very nice cooperation with them and with our IT department. And now we have something that is nice, where you can enter the data, where you can have all the pictures there, do the quality control, give the feedback, extract data, make visuals of that. So we are happy, and we look forward to provide this year the full 12 years data of the SeaWatch-B program. And to end up with last slide, data flow, what are the biggest challenges? Well, you will recognize the first one, this mistrust on data quality. We also saw that in our own institute in the beginning. You have to deal with that. Sometimes also it's underestimated the efforts you have to do in citizen science in terms of communication, data management, and of course the financial means you need. And finally, we have been struggling to get it structured, to get it anchored also into the institute, but now it's there and everybody starts believing that it makes sense. So I hope to be within 5 minutes.
My name is Lina Untana Nordlund. I work at Uppsala University in Sweden. I just want to mention that I'm on the GOOSE, the Global Ocean Observing System, their Biology and Ecosystems panel, and I'm in charge of the seagrass essential ocean variable. So one of the reasons why I'm here is I also want to sort of listen in to what citizen science, data flows, and what we can do and how that could also feed into the essential ocean variables. I'm also the coordinator of the BioEco Ocean, and I will tell you a little bit about the marine BioBlitz that we did this summer. So, I'll take you to the island of Gotland. It's a quite big island in the middle of the Baltic Sea. We don't have any tides. We do have a lot of people that love the coasts. We are researchers, and we wanted to see how do we collaborate. So we arranged a citizen science marathon, starting with the BioBlitz, ending with the BioBlitz. And the people that you see down to the right there, Åsa Eriksson and Florian Luskov, have been crucial in conducting this. So we wanted to do a marine BioBlitz. How do we get the data where we want it to be? So we were sort of debating. We need something that a lot of people are familiar with. So we were looking into sort of what sort of data is available around Gotland from citizen science initiatives. And we can see that most data was submitted via iNaturalist. So we went for that app, also because it can deliver data to GBIF. So selecting an app, in iNaturalist, the data that is sort of deemed to be research grade actually gets pushed forward to GBIF. So, I mean, we wanted to learn a lot. What's happening? How do we engage people? What is really the challenges of engaging people? And we have selected a framework to really go into the details of how do we sort of overcome different types of barriers, and also how to engage participants or stakeholders. We had a lot of challenges. We had a very low number of participants. As I said, we don't have any tides around Gotland, so if you want to take marine data or collect marine data, you actually have to be in the water. Actually, a lot of people found it very difficult to just install the app. I mean, step one to start collecting the data. And then when you're underwater, how do you get pictures that are good enough? What can you capture? How do you get that photo with the information that should be as accurate as possible, your GPS coordinates, maybe the time that you collected the data, into the app? So there's a lot of challenges, and like really start discussing how do we get over that, and how do we get or make the data collected in a good enough quality, so we can really turn this into sort of research grade. We have also looked into other types of apps. And next time, we're very curious of trying out COSEA from the platform Spotteron. And we also learned a lot. We need to have much more buy-in, and people need to be much more prepared and having the app ready, and really understand why it's important to collect all of these data. As someone said earlier, we really need to start by the observation to get the right data, to be able to actually contribute to fair data and have other people use this data. Thank you.
And please, if you have a question, also say to whom you want to address that question. Not from the room. Are there any questions online or? For Dave.
For Dave, yes. Do the data also go into the NVN in the United Kingdom for NI records?
We need a microphone.
Yeah, you need a microphone.
They don't directly, no. We share Northern Irish records back to our colleagues in the Northern Ireland Centre for Environmental Data and Recording, and then they share it to NBN from there.
Yeah, there's a question for Siggy. What do you think about the projects highlighted in Community Conservation Livelihoods, where communities approach conservation efforts independently? So their data collection, findings, action.
You? For who? I didn't hear for who.
For Siggy.
Siggy.
I'm not sure I can answer that.
Someone else?
Can you repeat the question?
So the question is, what do you think about the projects in community conservation livelihoods where communities approach conservation efforts independently?
Has anyone any answer to that?
Well, I mean, what do I think? I think fantastic. Isn't that the whole purpose of citizen science, to have community-driven data recording and action? Not just, of course we like the data, but we also like the data to do something and have good positive outcomes. So anything that contributes to ocean literacy and conservation should be welcomed.
Thank you.
There's also a more broad question on how a sailor living on a boat could support a project, and he's in the Mediterranean. So how would be the best way for him to contribute?
Haha. Who want to answer that one? The general one.
Is there a central platform where you can find opportunities for sailors? Because we also have that kind of questions. Very often people come, they want to sail across the Atlantic, they want to know how to do something in terms of science, and they offer their cooperation, but how can you guide them?
Does anyone want to talk in the microphone? No? Viviana.
We received a lot of questions from sailors. I think they can follow the project because for sure knowing about the sensors and knowing about the initiative that are already on sailing boats, they can be inspired from this. For example, Ocean Race and other initiatives that we will demonstrate during the project. And I think they will be able to follow some of the demonstration of the pilots that we will develop during the project. And they can contact us and also put in contact with the sensor developer. For example, some sensor that could be easily installed on the sailing boats, and then they can share with us the data. And so through the CS-MACH1 contacts, for sure they can be part of these initiatives.
Yeah, there is on the CS-MACH1 website, there are information to get in contact with us. Now I have 3 microphones. Careful, people. You don't want that. Yes?
Okay, another one is related to what you were talking about, is how can I, as a live aboard sailor in the Mediterranean, offer my support for the project? I think it's the same. And I just received one for Lina. How did you solve the challenge of individuals downloading the app and general use of iNaturalist to ensure research grade can be achieved?
So we had different stations around the island where people could meet with us, and we can help them to download the app. But I mean, it is a challenge. A lot of people, they weren't sure, is an iNaturalist, is it some commercial thing? Are you sure there's no hidden costs? So also a lot of information about the app and what it's for and what it does. I think that was quite important. You had the second part of the question that I think I forgot.
It's just one question. How did it solve the challenge of individuals downloading the app and general use of iNaturalist in order to ensure research grade can be achieved?
Also the part of the research grade. I mean, you need to get a good enough photo. And that is very, very challenging, especially if you bring up something from the water up to the surface. It might look very, very challenging. But I think it's very important about the communication and sort of the instructions and provide. We also provided, or we created also a photo guide to help people to identify things. So they might not have to bring it out of the water, even though they might have to take the photo. It is challenging. Yeah.
I just I have a question. So, right? Is there anybody else in the room that is using iNaturalist? No? Yes, Dan?
Just for research purposes. Just for research purposes. I'm not contributing any data to it, but the platform we're developing, Scuba Network, we're positioning ourselves to sort of be that abstraction layer on top of iNaturalist because it's not the most user-friendly. It's very scientific, and I think it's a really powerful tool, but I think we can build more simpler abstractions on top of it to just make it more user-friendly.
Thank you.
Well, in Belgium, we don't use iNaturalists because the projects on the Belgian coast are quite local. And of course, we know more or less the species, so you can take it on a more local scale. There's also an app that works here locally, that's Opsidentify, works very well. So some people use it, but because the area is so small, for instance, when we have our big annual seashell survey, we can have, well, like 10 different places where people can come and meet experts. And that helps also in terms of engagement and community building. But of course, you cannot do that when you have a coastline of a few thousand kilometers. We only have 65, so that's at least one of the advantages. Any more questions?
You have a question on Menti?
So question for Lina. Have you looked into using Artportalen instead of iNaturalist? If yes, what are the reasons you chose to use iNaturalist?
So we looked into a lot of different options, and we were looking at how many submissions there were in different apps. And on Gotland, it seems like a lot of people are using iNaturalist. That is why we wanted to try that, and also for being able to push the data to GBIF. Absolutely, we are aware of Artportalen. There is a lot of different apps, but we also wanted to go international because we want to make this sort of a European-wide thing. So we need an app that is suitable for at least all of Europe.
And how is the language in the app? You can change the language or in the settings or something like that?
In iNaturalist, yes, you can. But it seems like most people use iNaturalist for terrestrial observations. But, I mean, that's the fun of being a researcher, right? You want to try new things and you want to push the boundaries of everything.
We push.
Yeah, maybe with a local system I've mentioned, Opsidentify, we don't really use it to stimulate people to work with it and then upload the data there. But we just ask them to, when they have any doubts about the identification, that they can use it for identification and then still transfer the data to us so that we are sure to get all the data. And we do stimulate them to take pictures sometimes of species and upload them in the system to make that system better. Because of course, the more good pictures that are in iNaturalist or Opsidentify, whatever system, the more the system can be trained with artificial intelligence and the better it becomes. I remember when we started with the big annual seashell survey, initially those systems were really bad in terms of identification of shells. But of course, the more photos of good, good represented bivalves and snails that you put on the system, the better they become. And now they are more or less, you can trust them more or less. Yeah. So it's good to stimulate people to work with it. Any more questions? There's one more.
Okay, we have many comments in the chat. We cannot mention everyone, but if someone is interested about people that is recommending some web pages and some links to get in touch. So.
Yeah, there was a general question. I remember somebody asked whether the presentations and maybe also these things will be available after the conference.
Yeah, there were questions about the video. So we plan to do a report from the this workshop, and of course it's video recorded. So, but we need to, we have to have internal discussion to know if we're going to make it available and publicly, and where, and we need to have the consent of all the people in the rooms. And so there are different steps that we need to take before we can do that. But of course we will inform you, and we will circulate on any kind of social media platform and our website if and when it's out.
Okay, if there are no more questions, maybe we can take that extra time.
Yes, we can.
Okay.
Question just arrived.
Okay, good. One more.
Can the citizen science project be focused not only in collecting but also analyzing the data?
There are some. There definitely are some citizen science initiative. They interact at many different levels. They do collect, but they also do analyze.
Yeah, we tried something in between. So the SeaWatch data. Now this year there's a master student working on the data, and we asked that student to come together with all the SeaWatchers, so all the citizen scientists, to discuss with them his first analysis of the data, so the descriptives of the data. And that was interesting, but yeah, not every citizen scientist is interested in how you treat the data. Of course, they are interested in the final results, but that's different. So it was something we tried out, but not that so positive that we would do it again. Yeah. Okay, shall we close this session then?
Okay, let's go. Let's hurry up to the next one. We go from biodiversity to chemical parameters and litter. Peter, you're the first one up to 5 minutes. Tell us about ion water.
Introduced ourselves already. At Maris, we work on making marine data used and reused as much as possible. And in that context, we have also been participating in several initiatives around citizen science. And one of the most successful outcomes was the ion water initiatives, ionwater.org. And that was driven by based on the idea and the concept of the late Marcel Wernand, working at NIOS at the time. And he had the idea, okay, everyone has a smartphone, and he was an optical specialist, so why not make use of that camera on the smartphone to observe the watercolor? And the smartphone has a connection, it has the date, the time, the location. So you take a picture of the watercolor, and that helps me as an optical specialist to fill gaps or do, how do you say that? Confrontation against the remote sensing data, for example, and fill gaps there. And that was how ion water at the time originated, and since 2016, and we still keep it going. Technically, so this is an example of just a tool. We do not need to do the science, but we supply the tools, the means, and the platform for access the data, and then it's up to the researchers or citizen science groups to organize themselves, or together organize themselves with researchers and citizen scientists to start collecting data. And Laurence will give later a nice example of how it's been used. And you see here, it's an app, and it collects mainly watercolor data, but if you bring a SECI disk, for example, you can also observe the transparency, and you can fill that in also in the app at the same location. So you observe at the moment you click, and you get instructions in the app as a user how to do it, so not to have only glint or bottom. Sometimes when they're at the shore, it's very dangerous. You have the risk of taking actually a picture of the bottom if the water is too clear, and you get the color of the bottom and not of the water. So there's all kinds of instructions and to help. There's actually also the option to have other parameters via an entry form. That was done for CSRO in Australia. They handed out backpacks to observe and feed that in, but that's not used that much. So mostly it's on watercolor and transparency. At the moment we have about 24,000 observations, global coverage. And yeah, there's some stimulating tricks in the interface. Here you see the visualization. So everything you take within a second, it goes to the central server and we visualize it. And you can click on the dot and you get the observation. It's anonymized, but people can give themselves a nickname. And since it's an app, and indeed they require constant maintenance, so that is, yeah, that's always a challenge for us, of course, because we're underfunded, but we try to do whatever we can and keep the app alive, and that works very well. But they can give themselves in the app a nickname, and that nickname, if they want, and then they're not, they actually start collecting. So you see, yeah, user Linotte has made 177 observations already. We don't know who's using it. Yeah, we see the pictures coming in, but we do not know who's organized themselves. Sometimes we see something, all of a sudden, an activity in the US or in any kind of country. This one we know. That's actually a ship with a camera and submitting data to us. So that's an organized one. 1 minute already? Wow. So I could talk way longer about this one. But we, if you go to the data flow, we have an app, immediate transmission, data storage in the cloud, visualization immediately on the website, and there's 3 ways of quality control. One is automatic. We check the incoming picture with a Wacoli. It's a kind of a processing, and it extracts actually the watercolor based on Forel-Oele, the Forel-Oele scale, 1 to 21, automatically. But the users can also flag images from others, and they can say, this is not actually right, this is a wrong one. And we do a periodic quality check running machine learning protocol on top of it, and then we get all kinds of flags as well saying, okay, this is probably wrong, and then we can remove them. Data is publicly available via, for download, WMS, WFS, so for integration. And the barriers we have, yeah, always the data trust, but I think the more the users use them, the better the quality of the data is. Yeah, and long-term fun.
Good afternoon, my name is Laurence. I'm here from EPFL in Lausanne. I think I'm going to be the only one talking about fresh water this afternoon. But I just wanted to present our citizen science project on Lake Ginevra called Lemonscope. So as you know, remote sensing is widely used to monitor water quality at regional and global scale. However, these observations need in situ measurements taken on the ground to validate and calibrate these satellite images. So for now, on Lac Léman, or Lake Geneva, we have only a few locations where measurements are taken on a regular manner. So especially one point, the L'Explore platform, where we have sensors taking real-time data on many different parameters on the lake, everything accessible on data lakes. However, this is very limited in terms of space, so this is where we start this Lemonscope project. So we're collaborating with citizens around the lake to take measurements of watercolor and transparency. So the goal was really to collaborate with citizens having access to a boat or any other kind of embarkations on the lake to take these measurements. And we use the Ion Water app that Peter was just talking about. So we launched the project 2 years ago in 24, thanks to good media coverage on television and newspaper. We recruited about 700 people, of whom 250 received a 3D printed SecuDisc. So the color was measured very simply with the application Ion Water, so taking a picture with your iPhone, and people were able to measure the transparency of the water with a little 3D mini SecuDisc that we distributed. So we can see here that there was a real success. You can see the Ion Water map of Lake Geneva with all the measurements taken by the citizens. So we have more than 3,500 measurements. So Linotte, that you just mentioned, was one of our users. Yes. And we have about 2,400 SecuDepth measurements that were collected. So we have satellites going over the lake every day, Sentinel-3. So the idea was really to calibrate the images. So we have about 1,250 matchups. So all the observations were downloadable from Ion Water, so we didn't need any specific software. The metadata include the geographic coordinates, the time as well. So we just had to do quality control on the data. So of course, we had to exclude the data, the measurements that were outside the lake boundaries. The one that had a sort of weird SECI depth, so for example, the small one less than meter, or the one exceeding the meter of the SECI disk. So the SECI disk is hanging to a meter and is 20 meters max. So of course, all the data with more than 20 meters were excluded. We also used the local bathymetry of the lake, so all the depth that were actually more than the lake bathymetry were also excluded. And we had some weird measurements as well with out of daylight hours, but that's also was kind of weird because when we looked at the picture, we could see that it was full daylight, but somehow the time was indicating that it was taken in the night. So about the barriers, challenges, difficulties on the data flow, I would say we had to translate first the Ion Water app in French, so it can be used by the people. The weird measurements, we didn't know if it was a problem with the users, the phones, or the app, so this also is still questionable. And I would say the last thing, it was sustaining really the citizen engagement over time. So we can see on the graph the participation declined over the years, and it's we did a lot of efforts to maintain this engagement, organizing webinars, special events. We launched actually we have a next big event next week for closing the event, the project, to say thank you to all the participants. So I would say keeping the communication open is quite a challenge as well. Yeah, I think, am I on time or?
Perfect.
Yeah. Okay, thanks.
Perfect.
Good afternoon. So my name is Roman Lehner. I'm the co-founder and scientific project leader of the Sail and Explore Association. Sail and Explore is a Swiss marine science organization. We're a team of researchers, and we are focusing on the smaller sized microplastic fraction out in the open ocean. So we would like to make this invisible fraction, and I'm talking about plastics below 0.2 millimeter, visible with the work that we do. So on one side, we are conducting fieldwork, which is a combination between citizen science and research, right? So I'll present this in the next slide. But on the other side, we also have a very deep and strong collaboration with the University of Bern, where we also work on some other smaller size plastic topics, for example, nanoplastics. So we have figured out and established a methodology to make out of bulk plastics, food contact plastics, literally from these PT bottles, for example, the nano version, and these nanoplastics in the future will be used for human health studies, tox studies, etc., etc. So, but let's go into our citizen science work. So we're a globally active organization. So far, we have already conducted more than 27 scientific expeditions. As you can see, from Florida, the Azores, Mediterranean, all over to the Pacific, Samoa, and the Great Barrier Reef. On the right side, you can see also a publication from our site. Sorry, I think you can maybe not read it up, but you can also find it on our website. However, for us, it's very important that the outcome from our research is being published. It's being visible for everyone. So the data that we literally collect are mainly ocean data, right? GPS coordinates, time, speed, currents, water volumes, you name it, whatever you have to collect literally when you're on the boat. And on the other side, we also have beach plastics that we sometimes collect. For those who are attending this workshop also tomorrow morning, I will present a workshop that we have conducted and that we also have published in a peer-reviewed scientific journal. What is very important for us is that we do long-term monitoring so that we don't only reflect a snapshot of what we do. So we go out there and, for example, last year we spent 6 weeks around the Azores covering a time window of 2 months together with citizen scientists. to collect ocean data. So what do we do with the citizen scientists? Compared to others, we don't have an app. It's more kind of a controlled citizen science approach because we bring people with us on the boat. They support us with women power, obviously, for what we have to do. And together we can collect all the data. Best case scenario, they can also help us out later on and with the data analysis. So how does our data flow for the fieldwork kind of like looks like? So obviously we go on the boat, we collect all these ocean samples, right? These microplastic samples. That's in deep collaboration, as already mentioned, with the citizen scientists. They get educated on the other side also when they are with us on the boat. So it goes a bit hands in hands, which is great. And after that, it's a lot about data processing and analysis. This sometimes can also include the citizen scientists. Again, tomorrow I will present such a workshop study that we have published. And then at the end of the day, also, as already mentioned beforehand, for us it's very important that we publish this data in peer-reviewed scientific journals. And so far, we only have literally made the data also visible through this microplastic map through NOAA, but we are more than happy, obviously, to contribute our data in the EMODnet. Yeah, so what are our challenges or barriers or difficulties that we are facing for the fieldwork that we are conducting? So on one side, it's mainly financial support because, as you can imagine, we don't have by our own boat, for example, even though there are always good costs included and involved. And one needs to cover all these costs, but also then for the data analysis, etc., etc. And a big bottleneck, and I think that's the biggest bottleneck at the very moment in this plastic litter field, is the data analysis and processing. It's still very, for me, absolutely crazy to see that sometimes it takes up to 4 or 5 years until data is being published, and it cannot be that we are always looking into the past while we live in the present and we think about the future, but we talk about stuff that happened 5 years ago, right? And so that's something that we really try to push with our work. So we really aim towards 1 year max until it's being published, but I hope we can push it a bit, maybe more, even with the help and support from your side. Thank you very much.
Good afternoon.
Hi, Maria. Litter data management in EMODnet, right?
Yeah, thank you.
Welcome.
So, good afternoon all. I'm Eugenia Molina from the National Institute of Oceanography and Applied Geophysics in Italy. And I will briefly describe the litter data management in EMODnet and the citizen science contribution. Next slide, please. So in EMODnet, specifically in the chemistry component, we've been dealing with litter data management since 2017. And there are consolidated workflows for beach litter data, seafloor litter data from trawlings, and microlitter data, both floating and in sediment. Next slide, please. And these consolidated workflows are based on guidelines to format the data and tools both to help with the formatting of the data and to validate the data. We have received already a lot of data from citizen science, and we have good examples of citizen science organizations that, for example, are involved in official monitoring and are contributing to the European assessments of the MSFD, as Keep Students ID or Mare Nostrum. And because when data is collected using official protocols or best practices, and then, next slide, please, and then is curated in order to be fair, then when they enter into EMODnet, they become part of the data products, gaining, therefore, a lot of impact because data products, for example, validated data sets or other visualization products, can be visualized through and be accessible through EMODnet. but not only. For example, the validated data sets become part of the assessments in Europe. For example, the European macroliter trends that have been calculated in the past years, and they can also be part of global initiatives, as for example the GPML Global Plastic Hub data portal. The main challenges that we have with the data of litter is, for example, the quality assurance and quality control information for microliter data, the technical maintenance and the upgrading of the tools for data formatting and the quality control, and the automation of the data workflows, both to and from EMODnet. And that's it. I hope I've been in the 5 minutes. Thank you.
Emily, over to you, huh?
Okay, so now we're going to start also the discussion, which you're also moderating.
Oh, yeah. Oh, so interesting then. So let's check out if we have any questions first, huh?
We finished this this session, and now you can put question in the Q&A. You can put question in the Menti. Don't forget the Menti. We put a QR code on every slide. I hope the resolution of the broadcasting is better and allow you to scan anytime and put any information you want to share. Is there any question for our speakers?
Yes. Well, we start there? Okay.
So there's a question for Roman. Is there any way to invite data volunteers to analyze the data? Processing complex samples like eDNA would need a university support, but there are data analysts out there who would be happy to help.
Yes, that's possible, obviously. I mean, we're more than happy if you have people who want to help us and support us. We can teach them and show them. I mean, with the plastic citizen science thing, it's literally about, at the end of the day, we need spectral data. We need to really give proof whether we look at plastic or not. And that's solely possible in academia, right, for example. But other than that, there is a fair opportunity to support us, for example, to get in touch with us, to help us to look after all our filters, for example, to help to measure all the plastics, to count them, etc., because it's very time-consuming, and we're more than happy to get support on that.
And I was asked that if we want people online to see us, we need to look at the back of the room, which is a little bit awkward. So I'm not going to be too complying, but...
It's a bit odd, but we'll do it.
I have a question for Laurence. So you work ion water with physics, turbidity, things like that, color of the lakes then. We know from the inventory in Europe that the majority of the projects are working on biodiversity and mainly on charismatic species. I wonder how the perception is among the participants towards a variable that is physical, that is not that charismatical. You mentioned also that you try with all kinds of actions to keep that level high enough. What is your experience with the way they perceive working on physics instead of working with nice animals, dolphins, whales, whatever?
I think using this ion water application was, first of all, very easy. And being in touch with a lot of people participating in this project, I think there was a lot of enthusiasm, and receiving the little Seki disk, having the app is something so simple and easy to use. So I think it was applicable quite easily. So that's why we had a lot of these results, you can see on the ion water map. It was quite successful, but it's true that the next step would maybe involve more biodiversity, but this is, I think, more complicated to monitor, to assess, and this is where we have to see what kind of protocols we can use, tools. It might be a bit more complicated. It might be with maybe less people involved, maybe more passionate, more, it would be more difficult, I think. But yeah, people are really enthusiastic about the project, and I think some of them will be eager to continue. And this is where maybe we have to keep those involved and looking at some more specific parameters. Yeah, thanks.
Quick one, close one.
Yeah. No, I have another one from Menti for Laurence. How did you get the SECI disk and train the citizens? Can you explain also more in detail about engagement and communication activities?
Yeah, so the SECI disks were produced in the UK by a company called Brewtech. So they produced this mini disc, 3D printed mini disc, exactly for the citizen science kind of project. So there was a first publication actually from Ruin, where he published all the citizen science projects that were done in the world with this kind of little disc. So it's smaller than a usual SECI disc. You can easily put it in a backpack. We just had to manufacture a weight. You know, the thing is, they came, so it's basically a meter with a little disc, but you know, in order to avoid the disc to go with the current, so we had to add a weight. So this had to be produced by EPFL. So we have also some university, you know, so we could do that. And we produced, I think it was about 300 discs, and we distributed 250. We did, at the launch event, we produced videos. We showed very accurately how to use the SECI disc. And so I think people could go on a website to look at the videos. And we were, of course, like we collaborate with this association where people could come, call, ask questions. We had online forum discussions as well. We organized webinars in wintertime. In summertime, we did specific events around the lake where we invited people to come over. We presented the preliminary results. If there were still questions about the SECI disc or anything else, we were still there to explain. So the communication is quite important, I think, in this kind of project. You have to show that you are there for the people, and you have to keep them engaged. I mean, that's a real thing. Yeah.
A couple of questions. Question for Peter. What are the practical tips for making our data fair?
Haha.
Again, what are the practical tips for making our data fair?
Enjoy.
How many do you want? No, it's first of all, it depends on the discipline. To what kind of variable do you collect? Is it litter data? Is it biodiversity data? Is it physical data? So therefore, we have 3 sessions tomorrow to give an insight in what we foresee to be let's say the quickest steps to make your data fair. And yeah, I need to show some things on the screen, but it's, for example, that it's minimally, if it's physical data, that there's minimally a reference to the sensor itself. How did you collect it? That there's a latitude and a longitude in, and that the longitude is, for example, always recommended in WGS 84. So that we know where the location is. That there's always a date and the time in. Yeah, it's very logical, but we see already in cost-efficient sensors analysis that sometimes we get the first data set and there's no latitude, longitude in. Yeah, that's then it's immediately not reusable, so we miss something. And for the units and the parameters, as we already explained, there's vocabularies, so lists of codes. And instead of mentioning temperature, which is later, if you drop your data somewhere, somebody doesn't know, is it water temperature, air temperature? I don't know. So it should specify with a code saying it's water temperature measured in the water column, for example, including then also the depth. So those are things that you will see passing by tomorrow tomorrow morning.
Yeah. Follow us tomorrow morning. We here tomorrow morning, so we have more to say. Yeah.
Another one question for Laurence. You mentioned a drop over time in participation. Have you thought of involving local schools to sustain the monitoring interest over the years? Or are there major issues that makes it difficult or impossible? It's difficult or impossible?
So to maintain the community engagement, I think it's true that when we started at the launch event, because we had press release in the local press, also in Swiss television, so people were super enthusiastic. I love the lake, I want to do something for it. So they were all, it's like the beginning of a project. I think you have a sort of enthusiasm, and over the time, participation drops. I think it's natural, unfortunately, but to overcome this, so that's why I said during cold winter days, people are not going really much on the lake, doing paddle boarding or kayaking or whatever. So that's where we thought, okay, let's organize webinars. People can log in and, we talk about specific themes that the people chose. So we made a list of things that would be interesting for people, like invasive species, pollution and microplastic, this kind of stuff. And during the summertime, we organized guided visits to monitoring sites. We presented the results. We tried really, as much as we could, everything free, apéro. I mean, like they all like drinking and stuff. So they were just like trying to really, but it's true, it's difficult to maintain the engagement of the citizens. And talking to people, we had a lot of retired people. They have time. They love their area. They love their region. So I think people are quite passionate. But then, I don't know. That's why when we talk about biodiversity, I think it will be more difficult. Maybe we have a close, a smaller community, but we still would like to continue on that wave. Yeah.
I have actually one last question, which is for everybody who talked about app. I think I'm going to develop, the EU going to manage to make me develop a problem with the GDPR, right? When people are using app on their phone, you don't have this problem of consent, because then you know information about them, you know where they are, you know all that, how people who are using apps, how do you deal with that? So, I mean, Lina, you mentioned an app. Dave, you mentioned that it was difficult with app. You use app. I'm just.
Yeah, that's definitely important. First of all, you need, once they sign, in our case, once they sign up, we need to show them the privacy policy. Also, give them the option to be anonymous, and you have to set up to explain also in your privacy policy. How you treat the GDPR, what you do to protect their data, and that you only share it for this purpose. We had a very nice example with the Limascope project, because at a certain moment we got a request from the project saying, can we contact the users of the app? We know, but Limascope is not eye on water. So officially we're not allowed to share the email addresses with a third party. So the only the solution was to send on our own behalf a request to each of those users saying, because we knew who it were, we could see that in the location, and they knew we knew it. That was allowed, but to ask them, are you okay? Specifically to we had to do it in French. That we share your data with the project that you're involved in. Which was, I think, I don't know how many percentage said yes, because they were so involved in the project, it was not a problem, but you have to take care. Yeah. Otherwise, you're against the GDPR and you run into trouble.
Yeah, thanks. I think this is something I'm thinking all the time about, this app, and they know where you are all the time. It's like when you use your credit card. It's okay, we're going to have a break now, but we need to take a photo of the people in the room. Sorry, online. We will reconvene and start again at 5 sharp. We have a little stretch break. And in the room, please, don't run away. Where do you want the photo, Joseph? We'll gather in front of the screen here and we'll take a group photo. You know, we have to take these group photos.
Oh, yeah, I signed it. Good question.
Welcome back, everybody. Promise is the last session for today. Thanks for bearing with us. I hope you got your coffee online and had your little break. We took a photo, so we are all happy and ready to keep going. Antonio, I'll let you share the session, and we're going to start with that.
All right, good afternoon, folks. Pleasure to be here. Thank you very much for having me. My name is Dan Voice, and I am the founder of Scuba Network. Now, my background is in software development, but I like to escape this digital world by getting outdoors, and more specifically, I love to go scuba diving. Now, there's no better way to disconnect from this crazy world than to enter that crazy world. And I think a few of us can appreciate that here. But this world, the ocean specifically, is changing pretty fast. Now, divers are collecting a wealth of data that can transform not only how we dive, but help protect and restore the ocean. Scuba Network, the platform I'm developing, helps break down silos across the industry, enabling millions of divers around the world to make a difference with minimal effort. There we go. Our goal at Scuba Network is to make citizen science the default way to dive. Where have I got to point this thing to get it to work? So I'm going to get straight into the data. So the activity, scuba diving, but not limited to scuba diving. We want to make this accessible to free divers and snorkelers as well. But here's a visualization of a dive profile taken from a dive computer. These are the physical parameters. We're collecting this anywhere scuba diving happens, so around the world and typically in nearshore environments. I don't know how well you can see this with the contrast, but on the y-axis, on the x-axis is the elapsed time. Typically between 30 to 60 minutes is your typical dive time, but maybe longer if you've got good air consumption. And then on the y-axis, we've got the depth. Recreational divers will typically go no more than 40 meters, depending on their qualification, but technical divers can go down to 100 meters, but that's a smaller percent. So the blue solid line, we have the depth over time, and then you can just about make out the dashed line. We are capturing the water temperature. So here we basically have location, time, depth, and temperature. Now, this is just the foundation of what we're working on next. Biodiversity monitoring. Most divers these days will have a camera of some sort taking video and photos of pretty much everything they can see and observe. And by synchronizing the timestamps on the dive computer and your camera, we can then link observations and essentially plot them on the graph like this. With some sort of identification process, whether it's human or AI based or a mix of the two, we can then essentially say we've spotted a specific species at this location, at this time, at this depth, and at this temperature. So the physical data we're collecting today essentially becomes the metadata for our biodiversity monitoring coming soon. Still haven't figured this thing out. So the data flow. A scuba diver typically, but not limited to scuba divers, will use a dive computer, a camera, or maybe just their eyes. They'll share their data utilizing a mobile phone, tablet, computer to our platform, Scuba Network. We're web-based at the moment. Obviously, the data is stored in the cloud, returned via APIs, and we're working on mobile apps at the moment. And of course, consumers being humans and bots, science and policymakers. I want to give a quick shout out to the bots. I think this is quite a key thing I want to highlight, and one of the key design decisions from the beginning was to develop this web first. We're consuming data very differently to how we were 6, 12 months ago. We can't expect humans or our consumers to be utilizing or using our apps or our websites. We're all using Claude or ChatGPT or some sort of LLM-based interface. So we need to ensure our data is indexed and scrapable and all that sort of thing. Just to wrap up, accessibility, as I touched on before, we want to include free divers and snorkelers on our platform as well. They can collect data just as well as we can, particularly observations and access areas scuba divers can't. So having the name or the word scuba in our name isn't the most welcoming name, so we're changing our name to Descent, which, if I can get this thing to go, stands for Dive Science and Conservation Network. So yeah, coming soon. Thank you.
And I'm very happy to be here. Thanks for the invitation. And I'm not only a diver, also a sailor, enthusiastic sailor and water sports. And I'm running a private research vessel since more than 30 years. It's Aldebaran, and someone who is interested can take some flyers from me. And I'm dealing with this interface between citizens and science and communication for many years. And yeah, we have a similar project like Dan. And here, I can go to the next slide. So after running this boat, I founded a German Ocean Foundation because I see that we need this interaction and the dialogue between citizens, science, policy, and economy. And if we don't solve it, we really fail on this very beautiful planet. So millions of divers are diving, and since a few years the dive computers are very fancy and they have an interface with Bluetooth, so you can upload the data very easily, and divers do it. And the biggest network of divers is the Scuba Schools International Network. And because we are very closely involved with this Scuba Schools and the water sport industry, we started a project last year just asking if they will donate us the well-sorted and already uploaded data from the server, and we organized the communication and the link to EMODnet. So Antonio, thanks a lot for giving a lot of effort to bring this data to the public. And at the moment we have a trial of around 100,000 data inside, but maybe after this week we have around 10 million data worldwide. And this is really crucial because maybe you know that 93% of the heat is going not to the atmosphere, it's going to our ocean. And we now struggle with a lot of heat waves in the ocean. And I think that the scientific community cannot measure this in total. So we need citizen science in this part of the ocean, and we need it really urgently. So the system is really easy. So we have the system of Scuba Schools International with their app and the link between the dive computers and the database. And we already talked about this today. The accuracy of the data is not so perfect, and there's a long discussion in the science community is if 1 degree current accuracy is enough for science or not. And looking to the big heat waves, I think we need to accept this data. At the moment, we have no other chance, especially for data which are from areas where science are not able to catch the data, or on the surface where satellite data you can make very easily, but when you go to the deep, it's not so really easy. So it's primitive, and as we met here then, we also think about how we can engage other dive societies like PADI, etc., to go into the citizen science projects. And we are discussing right at the moment to open 2 open source apps, because I think it needs to have open source or apps to make it easy for all divers and water sport enthusiasts to upload the data. And we are also in very close contact with EMODnet, because the principle to upload also biodiversity data is a big challenge, and all the water sport people are very enthusiastic, and they are ready for engagement, and we need to involve them in science. And last but not least, let me say this, after You already mentioned this before. It's a very urgent part of democracy as well, to make citizens part of science and to crack down the walls of the ivory tower. And yeah, this is how it works. So at the moment, the SSI app is the central module, but we want to establish more apps, maybe one or two, maybe in combination with Scuba Network. And yeah, that's it. Maybe I'm a bit shorter. And but I think the involvement of the water sport people is very important, because only what you love, you protect. And we need to have this transformation, and we need to stand up in Europe to be strong facing the situation in the world. Thank you.
Thank you, Frank. Thank you very much. Hello, everybody. My name is Yuri Jurato. I'm the co-founder of Yotopon SRL, based in Cagliari, the capital of Sardinia in Italy. And Yotopon was founded as an innovative startup centered on the MACH1 project. Its main focus is on innovative, cost-effective environmental monitoring solution. And the main differentiation point is the mobile approach to data collection. Why is a mobile approach? Well, we have a huge gap in the traditional monitoring network stations. That is the spatial undersampling as far as many environmental variables are concerned. For example, we have seen up to 15 degrees variation over a distance of just 1 kilometer. And the same can be applied to variables like particulate matter or soil road temperature. What device sensor do we have? We have weather, we have air quality, and we have water temperature and other parameters that will come soon, and an infrared sensor for surface temperature measurement. At this moment, I'm measuring air quality and temperature and infrared temperature of the pavement here. Okay. What? Sorry?
We're doing good with the air quality?
Yes. At the moment, we have just 2 micrograms for meter cube PM2.5, so very good quality. And the MACH1 system implements the entire data pipeline, so from the output of the sensors to the end users' products. The collector are the citizens, vehicles, others means of transport like cable car. The sensor, I mentioned already them. And the next pillar is the internet gateway. We have an app, a mobile app, or a modem for to be placed inside the cabin of the vehicles. And through the cloud, we feed a huge database. At the moment, we have 1,120 million observations in our database. That, in turn, is the source for a number of data services, as you can see in the slide. So, citizen science projects, scientific studies, and many others. Observation protocols, vehicles as a sensor is our main way of collecting data. In Rome, we have collected about 20 million observations using the public transportation system as a mobile network. Tools are the sensors and the tools for data visualization, processing, and exporting. So we have API, CSV, and other tools. Standard and practices. In the citizen science project, we have seen that the most used approach is using bikes as mobile sensors. And for scientific organization, the public transportation system is the most easy way to collect data in urban environment for urban island studies. The main challenge has been designing, developing, and producing sensors that are low cost while maintaining, preserving high quality data and high reliability. And I think we were able to meet this goal with our more than 20 projects at a pretty high scientific level. And that's it.
Thank you.
We are very happy to see you because we had no news. So up to you. The floor is yours.
All right. Okay.
You can ask for the next slide, and we change.
Yes, please. So my name is Fernando. I'm based in Porto, in northern Portugal, and I'm together with my team. We have developed EMODnet, which is a family of rugged autonomous temperature loggers that can withstand very harsh environments, for example, the sea. The ocean, and they generate continuous and standardized high-frequency microclimate records up to 15 years in full autonomy. So I have one here with me. Let's see if you can see it. Yeah, it's a small disk. It can have many shapes like this one, which is meant to be attached to a boat, to the hull of a boat. You are mentioning these things. This one is one that is attached to some sort of wrist attachment, so a bracelet. So they can have different shapes. And now I don't see my presentation. Okay. Thank you. And this technology has allowed us to. I'm primarily a scientist, and I work with biodiversity and temperature, and how biodiversity responds to temperature. And so we created these sensors first to serve our science, but now we are actually selling them and distributing them among colleagues all over the world. But for us, we have established the CCT-BON, which is the largest rocky shore temperature and biodiversity monitoring network in the world, which covers most of the margins of the Atlantic, or the entire margins of the Atlantic, from one pole to the other, including the mid-Atlantic islands. And we are now starting to incorporate citizen science in this network. Next, please. So in this initiative, we are measuring temperature and biodiversity, but because this is a physical session, I'm only talking about temperature, although we are measuring biodiversity as well. So as you can see in our activities, you can see in the pictures, we have the temperature loggers, which are the gray discs on the left. Then you have a picture of a colleague of mine drilling a hole, because then we insert the loggers into the hole in the middle picture. And then on the fourth picture, you have a logger embedded on the rock. It's that green smudge, that circle on the foreground. And then on the right, you have us downloading data with a mobile app that we also developed. So the thing about these loggers is that they have this incredible autonomy of up to 15 years. They have very good precision, repeatability, and accuracy. They are very robust. We have a loss rate of 0.7% per year. They are cost-effective, and they are easily programmed and dealt with a smartphone with an NFC. And with that, we have been constructing this network. You have a map on the right. The orange dots are the places where we already have the sensors. No, sorry, the blue ones are where we already have the sensors. No, the orange, sorry. The orange are the ones where we have the sensors, and the blue ones are where we don't have the sensors, but we are in the process of deploying. And Our idea is to have this running for more than a decade. And importantly for this session, we are now, we have this distributed architecture, and we are now involving citizens in this. Next, please. So the data flow is, we go from, we use Android or iPhones with near field communication and a free app developed by us. We are working on the automatic upload of data from smartphone to the database. That is not automatic yet. So the second arrow in that scheme is not yet automatic. So that's a challenge at the moment. Then data will be served through an AirDAP server on the right. We already have a prototype version working with some data, but in fact, we want to have our raw data transformed in something that is really important for people instead of just serving raw data. And I think that will be more useful. But the
5
data
seconds, Fernando,
Okay.
5 seconds.
And another challenge is that we would like to add DOIs, so digital object identifiers, so that we can trace the contribution of the various citizens or colleagues that are working with us. You have pictures on the right, families on the top, and scouts in the bottom. We are trying to involve all these people in the network. Thank you.
Great, next slide. I'm going to share with you how a small sailboat that's built by students can spark transformative learning, global connection, and contribute to ocean science. Next slide. Educational Passages is a small, not-for-profit organization. We're based in the US, but we have a global scope and reach. Our uniquely designed 1.5 meter long uncrewed sailboats that are known as mini boats are built by students from a kit and outfit with GPS and sensors. It's like a message in a bottle, but better. What we've created since we became a nonprofit in 2013 is a low-cost, globally distributed surface observing network, powered not just by wind and currents, but by people. The boats produce data via cost-effective devices, one used to track corporate assets and another open source product. And I'll mention more about this in just a bit. All data are integrated and shared out so students and the public can access. The intent is for the data to be used by scientists as well, and not just for education. To date, we've launched 225 of these boats all around the world. They've landed in at least 36 countries, and we have an average 75% landing rate and made countless connections for everyone involved. Our tracks cover over 2.3 million kilometers so far. These boat paths create repeated exposure of surface currents, but also uniquely wind-driven transport due to the sail being above the surface rather than below, as a drifter would. The data collected and shared are location from the GPS, temperature with air on the deck, and sea surface at about 0.5 meter below at the keel, orientation showing how the boat is tilting and what direction it's traveling, and sometimes images from the deck. These images have helped us learn more about the sea conditions and their impacts on our boats, such as when the boats are capsizing or dismasting, as well as marine life out at sea. One time we found a bird that was resting there for over a week. These data are meant to complement traditional observing systems by filling spatial, temporal, and human access gaps at a lower cost. Our unique mini boat program also helps to inspire students to join the field as they become active data gatherers rather than just passive data users in the classroom. Next slide. Each mini boat has a main transmitter from AssetLink, and some have additional sensor packs with a rock block system from MakerBuoy. Both are Iridium, and the data are all sent and pulled via FTP to our hosted cloud server. And we have custom scripts that create JSON and CSV files that create individual maps on our websites with links that are the boat's names that the students get to name them, so everyone can track them online. And we also provide download files in CSV for those that want to explore further. Many of the challenges we face at Educational Passages are definitely not unique to us, as everyone in the room and online knows. One primary limitation is funding, of course. We're a nonprofit, but the public doesn't always see the benefit to funding a global initiative, so we don't always receive many donations to help with the data aspect of our work. We also have to prioritize connection and student learning. However, we are sitting on a massive amount of data and a data set that is truly unique that we want to share and have used. So I'm glad we're a part of this today. Thank you. We have data since 2010 with varying levels of metadata, sampling rates, and sensor types. The data are minimally QA/QC due to limited resources for script writing and database development work. But our current sensor data is also packaged up so that it could be cost effective through satellites. So additional funding would be needed there as well to produce a higher quality and resolution data, but it's all possible. So we have some work to do. Additional procedures can be implemented to clean up our data, to provide a higher resolution and quality, and to make it more accessible to a global audience. One step we've taken to achieve this is the formation of our Science Advisory Board last year. Patrick is one of our members. Thank you, Patrick. And we also welcome new partners and collaborators. So thank you for having us here as part of this workshop. And we look forward to finding ways to overcome these barriers and strengthen our impacts together. Thank you.
Sorry for having imposed to reschedule my presentation. But, okay, so, not this one. Which one? Which button? The blue? The green?
Yeah, towards there, maybe? Towards there? I don't know. Try.
Next. Thank you. That works, always. So I'm Paolo Di Viacco from OGS. And I would like to introduce COCAL, which is a citizen science crowdsourcing-based infrastructure that we developed at OGS, which means which is aiming to collect, process, and preview in real time on the web and disseminate in a fair perspective environmental data in several fields, such as marine physicochemical parameters, just like temperature, salinity, or dissolved oxygen, whatever. And air quality, I've seen before our presentation, just my arrival, but also noise, meaning urban noise. Next one. Okay, so the main idea is to leverage what are the, let's say, limitations of the traditional approach, which essentially the main limit is the fact that it's very costly. So this means essentially a reduction in, in coverage, both temporal but also geographic. And we try to leverage the power of the citizen science and crowd sensing to try to fill all these gaps that can be both, again, in the coverage in time, but also geographical. And so we developed for the marine data some kind of a torpedo that contains all the sensors, the GPS, and the transmission. But also in the case of air quality, we developed a box containing, again, sensors, and we install them on buses and cars, generally in public buses. And we have developed also an app, which is, of course, on Android and Apple, that measures the noise mainly in urban areas, okay? But all of these data just are integrated in an infrastructure where we store, we process, and we visualize and disseminate all the data that we need. Next. So the data flow is pretty easy. So we start from the sensors, we have the georeferencing, we transmit the data, of course we store it, we have some storage for that, we have the validation, which is very important talking about, let's say, low-cost sensors, because, of course, this is the limitation of most of the crowd sensing or citizen science approach, because, of course, since you have to provide volunteers with hardware, you can't give them 30,000 something tool, and so you need low-cost instruments that introduce several problems in precision and accuracy. And at the end of everything, of course, we have the mapping on the web and the distribution of this data to any kind of, say, also data sharing initiative. Okay, so we just wanted to highlight the fact that all the things we use, except for the sensors in themselves, we designed and produced internally at OGS, and also the apps is developed and the web portals, and also all the infrastructure, IT infrastructure, is maintained at OGS. And say, in a fair perspective, data is compliant with all the metadata and data standards in the distribution, in metadata, whatever. And we also provide DOIs. Issues, there are issues, essentially. They told me just to point 3, actually probably there are more than 3 issues, but the main 3 are the precision and accuracy they already mentioned, and we are developing an AI-based automatic correction system to correct data to some kind of reference stations, which essentially, in our case, is the environmental agency, the governmental agency that we consider the truth. Okay. And another problem is to steer volunteers, because of course they have generally the tendency to go to, we'll say, in very nice places, but maybe we are interested more in polluted ones, so there's something in between. We need some kind of gamification and other strategies to try to send them there. And of course, long-term investment that I already heard. That's it.
Thank you.
Thank you.
So yeah, as we did before, we open now to questions and comments from the room and from remote. But before doing that, maybe I ask the presenters, at least the ones that were here, to come closer, so it will be easier to pass the microphone. So if you, Dan, Frank, Paolo, if you want to come also on the stage or sit in the front.
Yeah, if
please.
you sit here.
Sit here. You're 3, 4, yes, 4. You need another 4, another chair. Let's do like that. Yeah. Okay, so is there any question from the room?
Yeah, I actually had a question for Cassie. I might have missed it, but I was wondering what happens with the mini boats after their lifetime. Do you like pick them up again, or how do you get them back?
I think it's difficult to get the person online back. Okay. So, question for people online, we're gonna have to solve. She's back.
You have it. Great, thank you very much, guys.
Our goal is to have them keep going for as long as they possibly can. Sometimes they just end up on the school's bookshelves on display. Some are still going around. We've got one from 2016 that has already circled the Atlantic with 5 different countries so far.
And is there then maybe a way that if someone finds it at the coast, that they somehow can equip it with new sensors and just push it back, or?
Yeah, absolutely. We've upgraded a lot of them. That one I just mentioned was upgraded with the sensor pack, the air, water temperature, orientation, and the camera. And that's the one that actually had the bird over in the Turks and Caicos that it captured. So yeah, we want to keep upgrading them. One thing we also want to add is salinity. Now that we have the system that works, we want to collect as much data as we can.
It's Patrick here. Hi. Hope you're doing well. Yeah, it's over there somewhere. Haven't you had a couple of boats that go from the US over to Europe, and then it picked up by schools over in Europe who ship them out again, right? And then they just keep going, like back and forth.
Exactly. That Gulf Stream likes to take them over to you guys, but we like to send them back around and see what happens.
That's very cool. I like it.
Is there any other question? Yes, please.
I have a question for Dan and Frank. How do you account for computer accuracy and inertia and accuracy of reported location?
Yeah, so the accuracy is in the GPS. I think it's not a big deal to have it, and the accuracy of the temperature. We are talking to the manufacturers of the dive computers with the big companies and try to figure out. So at the moment, it's a bit of uncertainty because we expect temperature accuracies between 0.1 and 1 degree. So we don't know, but the manufacturers agreed to make a series of experiments to find it out.
Yeah, just to add, I think a lot of the models are sort of consistently inaccurate. So we can, if we're collecting the model and make, we can correct the data to a certain extent. But I think it comes down to the use case of the data. For certain scenarios, it might just be fine. For others, just not going to be okay. So yeah.
Yeah, second possibility could be to calibrate them. So each diver could make a calibration at home, but we are still in the beginning stage of the project.
Yeah, exactly. Yeah.
So we agree.
We do agree. Yeah.
I think one point that you raised that's quite important is to have very good links with the producer of this sensor, or at least the ones that are including packing them into the diving computer, because if we can access the data sheet of the sensor back to back with the data, then we have a lot of people that can help with at least the correction of this sensor. So that could be one target that we may have. Is there any question from outside? Yeah.
Yeah, it's just a general question out of personal interest. We talk about physical measurements. I may have missed it, but are there some low-cost water current measurement tools available on the market? Because I see some opportunities there in terms of rip currents, whatever, safety of swimming, other things. Of course, indirectly, turbidity, transparency of the water can do something, but this is not exactly the same.
Who wants to take this one?
Yeah, who wants to take? No, I mean, this is a good question, and that's the question we have often when we talk about Scoop and the devices in there. People are often asking about the current. And as far as, I mean, we keep searching for it, and as far as I'm aware, we're not there yet. So
another one of these that people are start asking for is low-cost HF radars. They're like there are two big companies competing and keeping their prices up there. The one who comes up with that idea, Juan, that's going to be a nice market. That's for sure.
The time I need to go back to the.
Is there any other question from the room? Otherwise,
well, one was for Dan, but I think I recovered partly. How do you account for computer accuracy and latency?
Yeah, I think we sort of touched on the issues with the temperature sensors. Typically as well, when you're entering the water, the diving computer will take up to 5 minutes to get to its actual temperature. So that first 5 minutes of data, you pretty much just got to scrap on average. But yeah, we can apply sort of correction to the temperature to a certain amount. But again, there's so many variables in place. The ultimate solution is to put better sensors in them. So it's quite a big job.
Yeah, it's not about only about the sensors, it's also about the design. So when the dive computers were developed, nobody thought about to have a correct temperature measurement in the dive computer. Now they start think about where to put the sensor and how to put the sensor to make it more accurate. So we are in a dialogue, and we will see results hopefully soon.
Which is valid for any other type of devices. I mean, we work with a device from which has been designed for fishermen, and they have the light attenuation in it. It's a little thing big like this, temperature, conductivity, and light attenuation, which is very interesting. And it is very much depending on the way it is in the water and moving in the water with the design of the hardware.
I have it in my wallet.
Yeah, it's and it's deployed by fishermen.
Cassie is no more online, I think so. Yeah. Oh, just a question for you have long-term deployment. So for the falling on the sensors, there is something that you on which you work, or some, I don't know, because it can the accuracy of the sensor could change in time for the falling, no?
Yeah, no, absolutely. The new water sensors are fairly new, the last couple of years. So we have the students, you know, paint the bottoms with the anti-fouling bottom paint, but we have a lot more to do in terms of how fast that growth is happening and is it very successful on the other side when they get there. So that's still more to work on, and another limitation with adding salinity, for example, which would be much harder to keep clean for data accuracy.
All right, I have two more. I think this is related to Cassie. The first one, it's a great initiative, thanks. We've been running CS project Sail for Science for 2 years, collecting CTD and BGC, high accuracy web subsurface data from a sailboat in the Caribbean, sailforscience.com. I think that relates to you. And then the other one is, how do we get involved in the Educational Passages project?
Send me an email.
That's easy.
Yeah.
Or
lots
come
of
up to me.
opportunities. I'd love to chat. Yeah. Or ask Patrick.
Yeah, anyone in the room, have a chat with me. Yeah, okay. If it's online, it's over to you.
Maybe I have a question for Yuri and Paolo, because you are doing activities related to both, let's say, the meteorological parameters and water parameters. Which are the communities that you can involve easier? And which are the main challenges with to involve the other ones?
So first of all, as I mentioned in my presentation, we do have problem in general and involving volunteers, since we do not have the personnel to do only this. So we are mainly devoted to developing ideas, developing the infrastructure, hardware, and things like this. So that was our main. And then we try to, of course, provide case studies, or, well, say volunteers appearing magically somewhere, to provide them with say, our tools. So the community we experience more were, say, the marine one, because we have more contacts, and of course the mission of our institution is in that direction. And it was actually, from our point of view, it was a kind of a niche to try to install both marine and air quality, because especially in our case, in our city, which is a city on the sea, is Trieste, that we have strong winds, and of course, after, let's say, 1 week of, or even a day, just a day of strong wind, of course, everything in the area is clean, pristine. So we always wonder where these masses have gone. So we have tried to study both the things with, say, volunteers boats that try to map the movement of air between the city and the sea. And that was very nice and very easy, since we already had the marine volunteers. We also had the air stuff. So maybe there are, let's say, overlap cases where this can be done easily. In general, in my experience, the marine ones are more enthusiastic for this kind of approach, while the others are less.
What's about your experience?
Yes, we are a solution provider, so we look very carefully to citizen science project manager that can help us to provide the best sensor devices, software infrastructure, and in general data processing. So we are looking for partnership and collaboration to improve our products, basically.
Okay, I have some sign from the back end that we need to close now. So I want to thank you again, you for being present, people from remote, for the very nice presentation. I guess it's also, we are closing the meeting. Do you have any words?
Closing for today.
For today.
We have few points to but first, that's really good.
So
There's a lot of conversation. We on time, and we have a lot of things we want to talk about. So we have tomorrow morning. In the room here, we have this evening. So it's not game over for the question. Keep them and the discussion. And you wanted to point something? Yes. I will say the last word.
We actually just put on a question on Menti for everybody who is still online there. What is the most significant thing you learned today? We want to know what you took away from today. And we do have a general overview feedback question after that, if we're still allowed to do that.
People don't want to run away. Yes, sure, we'll do that. Actually, for the questions were for tomorrow. That's why I didn't mention it. But sure, let's take the minutes.
And for the people that are online, we will really thank you.
Yes, we really thank you very much. So this is the QR code, and so we see the results now.
And again, for the people online, please keep filling the forms and the Menti. We are really eager to see your comments, and we will come back to you. We want to plug also the last one.
Maybe give it 10 more seconds.
10 seconds more for this one, then we fire the last one.
And in the meantime, tomorrow we'll start at 9 sharp. So, yeah, be there in the room a little bit before, please. And we'll do the first talk.
I have to say that this sharp timing is a bit clashing with my Southern European attitude.
What should I say?
But as you can see, I was really sharp in coming.
Right on time.
We are not seeing those results because we don't want to bias people. Yep. All right, I mean, we can leave this on and you can close and people can still respond.
Of course, then I'll do that. Well, thank you, everybody. Thanks again. And I'm looking forward to see you tomorrow. Thank you.